Afternoon to all participants from Malaysia, Singapore, Thailand, Indonesia, Brunei, Philippines, Vietnam, Japan, and Australia, very Asia Pacific, and also good morning to our speaker, Professor Grün from Germany. My name is Engineer Yeong Jin, your moderator for this webinar. First of all, on behalf of MASHRAE Malaysia chapter and the Institutions of Engineers Malaysia IAM, I would like to welcome all of you to this webinar on resiliency against airborne transmission, IAQ post-pandemic. This webinar will start now and end at 5 p.m. after the Q&A sessions, which will begin at 4:45 if we are on schedules. We have invited the panels of 5 prominent speakers from the academia, research institute, and industry leaders, each of whom have in-depth knowledge on the subject matters and have impeccable expertise, experience, and credentials. They are none other than professional technologist, Dr. Yeong Jin, Engineer Chen, Engineer Chong Han, Professor Gunnar Grün, and Mr. Daniel Lu. I'm very confident that you will receive excellent information and knowledge from this seminar when it is over with. Now, before I begin to introduce speakers, I wish to inform all participants to take notes of the information in front of you, especially on the mechanism on Q&A and others. And this information will also be posted in the chat box for you to know. The key among all is there will be no Q&A, which is because you will not be having the availability of the mic. So all questions to the speakers are to be entered into the chat box. Secondly, there will be no Q&A immediately after the presentation of each speakers. Okay, if you have any questions on these, please type into the chat box and we will respond to you. Okay, I think we have started running short of time. I'm pleased to introduce to you the first speaker, a professional technologist, Dr. Yeong Jin, who will deliver a paper on an overview of prevailing applied practices and solutions to mitigate airborne transmission. Let me introduce you Dr. Kin's credential. Dr. Yeong Jin graduated with a PhD in mechanical engineering from University Technology Malaysia. Since 2008, he has actively involved in the R&D activities. He first joined the Keppel Offshore and Marine Technology Center, Private Limited, Singapore, Comtech, as a research scientist. He then joined the University Tunku Abdul Rahman, or UPA, in early 2010 as a lecturer and continued to be actively involved in the research activities, including noise and vibration, renewable energies, applied mechanics, HVAC, and others. Besides his involvement in research work, Dr. Kin is also active in providing consultancy and industrial solutions to the industry. He is currently the head of the Department of Laboratory Management and Safety Administration in Lee Kong Chian Faculty of Engineering and Science, University of Tunku Abdul Rahman. He is also currently served as the president of MASHRAE Malaysia chapter and is also a member of the MASHRAE Epidemic Task Force. He obtained his professional technologies registration in the year 2019 from Malaysia Board of Technologies. Long credentials which I have shortened. With this, over to you, Dr. King. The floor is yours. Thank you.
Thank you, Engineer Ong. So we have today my topic is on just an overview on the applied practice and solutions to mitigate airborne transmissions. So my name is King. Okay, so let us look at the contents of my presentation today. So basically, I will just introduce some of the overview of major recommendations worldwide, as well as in Malaysia during the pandemics. And then some brief on the MASHRAE position papers on the infectious aerosols, and also the newly released for comment MASHRAE standard 241P, control of infectious aerosol. So then we will continue with the cleaning and disinfection solution, some of the technology available, and then summarize my today presentations. Okay, so I think all of us know that the World Health Organization, WHO, actually released this roadmap to improve and ensure good indoor ventilations in the context of COVID-19. Right. So those who are in the healthcare industry or healthcare setting, especially like hospitals, we know that the recommendations for the AGP activities actually is 160 liters per second per patient, or actually 12 air change hours. So for others, watts is actually recommended at 6 ACH. So I think one of the key things here when we develop the guideline in the healthcare, we're talking about these airflow directions, right? So this one, a lot of laymen will actually do not understand much, because for hospitals, then we have to identify where is the highest risk, so that we make sure that we are not blowing the virus from the patients to healthy persons. Okay. So other recommendations are like air should be exhausted directly to the outside, away from air intake vents, people and animals. So as well as the HVAC system should be operated continuously when people are in the buildings, and should be regularly inspected and maintained, and also clean. If we move on to the recommendation under WHO for non-residential setting, it could be the offices. So if we talk about 10 liters per second per person. Okay, so the idea here is actually to dilute the contaminant so that the risk of infection is lower, right? So this actually linked to the occupancy, the ventilation rate in the space is highly related to the occupancies of the room. So during that time, the recommendation is if the ventilation rate is not sufficient, so one of the approach we can do is to reduce the occupancy in the space, right? So besides this, verifications on the air recirculation system, heat recovery system, and also reminder to operate continuously the HVAC system when there are people in the buildings. So make sure the HVAC system are inspected, maintained, and cleaned properly. So the other one on this residential setting, including home and self-quarantine at home. So the ventilation rate is still kept at the 10 liters per second per person. Okay. So for quarantine, that's why there is a recommended of separate the isolation area from the rest of the house. So if the home has a HVAC system, then it's also should be regularly inspected, maintained, clean, and operate if there is people in the house. So this is a diagram shared by WHO on the good ventilations protects from COVID-19 infections. So we can see that the first icon here is actually talking about good ventilations, right? So one of the easiest way to achieve it is to just by opening the windows, especially in the house. So to let the natural ventilations, right, to allow natural ventilation in house. So in the event that the ventilation rate is not sufficient, we can actually use the mechanical fans. But you'll find that the recommendation here is to place the pedestrian fan in front of the windows and facing the outside, right? So this one mainly is to make sure that we are the airflow directions. We are not actually blowing the air to a specific directions. So in case the patient is sitting in front of the fan, if you blow the air from the patients to the other healthy person, then you will increase the chance of infection. So that's why the recommendation over here is to place a fan and then blow the air, actually to drag the air out from the house through the windows. Okay. So alternatively, we can also use the air filters, okay? And also, if we are in the cars, right, during that time, we also recommend turning on the outside air intake button. So if you are on your vehicles, right, later on you are in your vehicle, you can search for these icons. So besides all these ventilations criteria, actually we should also taking care of all other practices like distancing, physical distancing, sanitizations, okay, masks, and so on. That is for other control measures. We move on to this EPA, right? The US EPA, Environmental Protection Agency. So again, it mentioned about the ventilations, increased ventilations of outside air, right? Or we can also improve the natural ventilations. So so if you are using the HVAC system, again, we can looking into upgrading the filters. And then if there is a budget allowed, we are recommended to use the portable air cleaner or air purifiers. So if you look at the CDC actually recommended 5 ACH, 5 air change per hours of clean air in the occupied space, right? So and then the minimum filter recommendation is MERV 13, and then for office buildings during the time when there's a lockdown, when there is no for a long time there is no people occupying the buildings, so there is recommended of flushing the buildings air. So this one also, if possible, during the peak times of these COVID-19, there is also a recommendation to flush the air in the buildings during the change of the occupancy group. Right? So other alternative air disinfection or cleaning device can be applied, like portable air purifiers or even UVGI. I browsed through the websites, and then I found this REVA, the Federations of European Heating, Ventilation and Air Conditioning Associations. Actually, recently, December 2022, they actually published this health-based target ventilation rate and design method for reducing exposure to airborne respiratory infectious disease. So this is I would say that this one they are targeting on the post-pandemic, right? Post-COVID ventilation target ventilation rate. So this is to complement the existing ventilation design method in non-residential building, excluding the healthcare and industry building. So over here, it actually talk about health-based target ventilations. So this is not a normal ventilation rate. This is on the higher ventilation rate when there is a suspect this aerosol infection cases. So the ventilation rate is recommended to be increased for occupied space we can run it with or without the filtration removal rate by the portable air cleaners. So there is long calculations there. I have shared the links at the bottom. So if you are interested, you can download the files and look at the calculations. The other one is on the ventilation control, because at the moment some system actually is using CO2 as a set point to turn on the ventilations. So the suggestion here is we can lower down the set point to 550 ppm, right? Instead of a higher ppm, so that to allow the ventilations to kick in earlier when there is only a few people in the space. So how about the European Center for Disease Prevention and Control? So I just picked two of their documents. There's a lot of documents that you can refer to. So one of it is considerations for infection prevention and control practice in relation to respiratory viral infection in healthcare setting. The other one is the heating, ventilation, and air conditioning system in the context of COVID-19. Right. So for that, again, the first item to highlight here is we are asked to review, maintain, and monitor the HVAC system, right? Possibly changing the filters, right? And then to meet the minimum number of air change per hour with the applicable building regulation. And then also the CO2 can be used as a monitoring parameters. But for CO2 monitoring, this is a tricky one. You have to know that because normally CO2 will increase because of the increase of the occupancy in the room. So there is also a suggested measurements of measurement method for obtaining these CO2 parameters as monitoring parameters, right? And then review the airflow directions, also to avoid use of air recirculation if possible, and also suggestion to use those air cleaning devices, for example, the HEPA filters and the UVGI. So for National Environment Agency Singapore, NEA Singapore, so there's also a lot of information we can find from them. First one I pick up is advisory on the CO2 monitoring to assess ventilation adequacy. So this is as well I mentioned just now. If you want to use CO2 as the monitoring parameter, we have to know how to use it. So you can. This is one of the good articles that you can take a look if you would like to use CO2 as a monitoring parameters. And also there's an advisory on surface cleaning and disinfection for COVID-19. Right? So it covers surface cleaning and disinfection, not just the air. And then also the advisory on the use of UVC sterilizer in the home. So updated guidance on improving ventilations and indoor air quality in building for healthy indoor environment. So you can see that they are from NEA, it's still saying that we emphasize on the ventilation systems. The ventilation system has to be in a good working orders, right? And then air purgings can be rapidly remove pollutants from a space. And then we can also improve the air filters to reduce the indoor air pollutants by trapping the microscopic particles like dust, mold spore, and other airborne pollutants. So the reason of increasing the ventilation is to help to dilute the concentration of pollutants and the airborne microorganism. So the high ventilation rate must always work together with the good airflow in the space. So and then increase ventilation and enhance the air exchange in the space. So for those space that initially without exhaust fan, then we can also consider of installing the window mounted exhaust fan to enhance the ventilations, right? I think one of the examples I share with my friend is actually I'm also doing this for my house, right? During the COVID, actually I installing the exhaust fan on my first floor as well, instead of just kitchens. Okay, so this because I using the CO2 monitoring, and so you'll find out that the air is stagnant when the CO2 is. You find out then when the air is stagnant in the room, the CO2 level will increase. Once you put in the exhaust fan, basically you can reduce the CO2. In other words, it also somehow means that we are improving the circulations of the air. So portable air cleaners can also be used for localized air cleanings. So if you notice that when we talk about portable air cleaner, it's more like targeted locations. There is limitations of the space that the portable air cleaner can serve its purpose. So also we can consider on the upper room UVGI for the air cleanings. So in Malaysia context, we have I pick up two of them. One is from DOSH, the Jabatan Keselamatan and Kesehatan Pekerja. So they actually published the 4 guidelines, the panduan. So one is for the public area, kawasan awam. The other one is the second one is on the tetapan kediaman, there is a residentials. And then the tetapan bukan kediaman is a non-residentials. And then the tetapan kemudahan penjagaan kesehatan is the healthcare setting. So I've just checked the DOSH website is still available, so you can still download the information if you are interested. So if you look at that, basically it still go around like the recommendation is still very similar to other countries. Mainly is to increase the ventilations, either through your aircon system by increasing the outdoor fresh outdoor air, or actually by installing an exhaust fan or natural ventilations. So under the Ministry of Health, sorry, I pick up 2 of the documents. Actually, the bottom one, the policy and procedure on infection prevention and control by Ministry of Health Malaysia. This document actually published in 2019, before COVID. So basically, this document really is quite comprehensive. So it covers the PPE, disinfection and sterilizations, the AII room, right? And also the ultra clean ventilated operation theaters. So if we can fulfill this policy and procedures on this infection prevention control 2019 by the MOH, basically the setting here will be able to handle the COVID-19, right? But in view of COVID, a lot of, especially like the clinic kesehatan, the small clinics and older hospitals. So actually the Ministry of Health working together with the University of Malaya Medical Centers, actually come up with another guideline, right, on the ventilations in the healthcare setting to reduce the transmission of respiratory pathogens. So which is the Annex 52 that can be also found in the Ministry of Health website. So again, its recommendation is aligned to WHO, right, on the 160 liter per second per patient for the AGP case, and then 6 ACH for the outpatient department. So the few examples actually available in the guideline regarding the airflow directions, air cleaning, and also the negative room, right? How we can place the patients safely in the ward, right, through this negative room. Then we move on to the ASHRAE. On October 2022, ASHRAE Board of Directors actually approved the ASHRAE positions on the infectious aerosol. It's actually to advise policymakers on appropriate engineering control strategy for various settings. So you can see here, we are talking about various normal and also the epidemic disease states, and in a combination with the non-engineering strategy. So this has to be based on the best available science. And then the numbers of benefits and costs resulting the various strategy, including their carbon implications. But we know that by increasing the outdoor air and or the outdoor air, especially in like Malaysia, so your HVAC system, your air conditioning system, have to work harder, and it will actually contribute to a higher energy consumptions. So and then so this one give the position of ASHRAE to look into recommendation for better practice based on the available evidence and technologies. So in recent, I think last month, if not mistaken, so ASHRAE actually come out with this ASHRAE standard 241P, control of infectious aerosol. So this provide minimum requirement for HVAC related measure to reduce the risk of transmission of COVID-19, influenza, and other airborne viruses in home, office, school, hospital during period of high risk, right? So you can see that this is not the minimum requirement for normal building, but it's during the high risk period when there is an outbreak. So the standard offers guidance for creating healthier environment in the building where we work, live, and play. Actually, now you can log on to the ASHRAE websites. So the link is shared at the bottom here to download the draft of these ASHRAE standards and take a look onto it. I think later on, Engineer Al will also touch a little bit on this ASHRAE standard 241P. So for this ASHRAE standard 241P, so the standards actually address the long-range transmission of infectious aerosol, and also the minimum requirement for here is a equivalent outdoor air for the use during the infection risk mitigation mode. So you can see that now we are not simply talking about outdoor air, but it's an equivalent outdoor air, right? As I mentioned, if we just drag a huge amount of outdoor air, that actually will impact on our energy consumption of the buildings. And then room air distribution to reduce the risk, right? So this is related to the air distribution method. I believe later Engineer Chen also will touch a little bit on this air distributions in the space. And then characterization of filters and air cleaner effectiveness and safeties, right? Commissionings, including development and implementation of a building readiness plan, system operations in the infection risk mitigation mode during period of high risk. So one thing I always emphasize here is maintenance, right? Maintenance tasks and their minimum frequencies. So this is very important. So now we move on to look into what are the available technology in cleaning and disinfections. So I think most of us are already quite used to air filtrations, because during the peak of COVID-19, there's a lot of discussion on air filtration, especially on the HEPA filters. Okay, some also talking about electronics air filters, gas phase air cleaners, in room or portable air cleaners, and also other combination air cleaning options. So the other air disinfections, right? Disinfection technologies that include the UVC, right? The PCO, the photocatalytic oxidation, right? And also the ionization, right? Ozones, as well as the portable air cleaners. So the portable air cleaner is classified as here because a lot of portable air cleaners is not just come with the mechanical filters. They also a lot of them will actually equipped with the UVC as well. And then the third one is the surface disinfections, right? So this is on the spray and white chemical disinfectants. We can also use UVC to do the surface disinfections. The vaporized hydrogen peroxide. We can also use ozone. This one already surface disinfection is actually using ozone is quite common actually in certain industries. And also other ultraviolet lights that we can use for it. So for mechanical filters, right? We have been seeing that a lot of recommendations saying MERV 13 and 14. So that is basically based on the studies that we have. For example, the left-hand side, the tables here show the relative risk of influenza infections in the case study office. So you can see that the MERV 13 and 14, the relative risk is low if we compare to even the HEPA. They are quite equivalent, right? Because by using HEPA and MERV 13, the pressure loss through the filters is actually quite huge. That will end up having a drawback on the energy consumption of our system. So over here, most of the experts actually just recommend MERV 13 or 14 would be good enough, right? But and HEPA will be optional or more luxuries in another say. So on the right hand side, there is on the operating cost, right? So if you increase the outdoor air because you have to increase your cooling load, basically your annual cost will be higher compared to just upgrading your filters. So for electronic air filters, right? So wide variety of electrically connected air cleaning device. So we have to look into the overall effectiveness of this device. So depending on the removal efficiency, airflow rate, size and number of particles that it can trap. Okay, and also location of the filters where we put the filters, and also remember that we have to do maintenance and cleanliness of these electronics filters. So for gas phase air cleaner, basically this to remove the ozone, VOC, and all those, right? So at the moment there is no solid evidence that saying that this gas phase cleaner is useful for removing the COVID-19 viruses. So then UVC, this is also a hot topic during COVID-19. So UVC can be installed in the induct air disinfection upper room, right? Or induct surface disinfections, or even the portable room decontaminations purpose. So UVC is actually harmful to humans. So if you are handling the UVC, you need a special PPE for that. So for ionizations, right? So it use reactive ion or reactive oxygen species to do the disinfections of the air. So again, we still need a lot of studies, right? Especially the scientifically studies to get more data to support these technologies. So when we are using all these technologies, you have to be very careful on the reliable of the test data and also the efficiency of the system. We also notice that there is a lot of equipment claiming they can generate ion, ozone, and so on in the market, but there is no proven test data, especially from third parties test lab report. So for portable air cleaners, we follow the calculations based on the Association of Home Appliance Manufacturers. So we are calculating the CADR. So if you buy an air purifier, they will suggest you how big is a space they suppose the air purifier can cope with. Yeah. So this is basically based on 5 ACH, and the room height is if not mistaken is 8 feet high. So there's other emerging technologies available in the market. So ASHRAE welcome data and the third-party test report to be presented to the respective technical committee. So this will provide a better guidance to develop a proper standards for the new emerging technologies. So in summary, COVID-19 is already proved it will spread through the air. So air cleaning can help mitigate the disease transmissions. So option for air cleaning include HVAC system and in-room devices. So technology available are mechanical air filters, the air cleaners, UVC system, or other emerging technologies. So here we have to emphasize again, care and professional judgment is needed to understand the choice of the filtration and air disinfections, and also their pros and cons and the impact on the existing building system. So just to recap, ventilation is important. And also we have to check the design, installation, commissioning, and maintenance of our HVAC system. Because all the technology has its limitations, we have to use it wisely. And also all the while ASHRAE is talking about indoor air qualities, because it's not because of just COVID-19, it's because of the human health as well. So other approach, we have to combine with other approach like administrative control, personal protective behavior, and control of source to keep everyone safe from this infectious disease. So maybe before I end my presentation, I throw some questions that you can think of it. So how should we design our HVAC system? And then do we need the two broad set of operating system, what we call it the normal and epidemic states? And how to maintain our HVAC system? And also think of someone, if someone claims that there's a maintenance free system, then you have to think carefully. So that's all from my side. Thank you very much.
Thank you very much to Dr. King for the comprehensive sharing of the recommendation, also the mitigation measures for the airborne transmission, especially those recommendations from USA, CDC, WHO, and those from Singapore, European, and also our own Malaysia, the Ministry of Health, and also Department of Safety and Health, and of course the ASHRAE position paper. Thank you, Dr. King. For those who have questions, please key into the chat box, and we will answer your questions during the Q&A sessions. Thank you. Next, I would like to introduce our second speaker of the day, none other than Engineer Chen. He's going to share with us a critical review of the effectiveness or otherwise of the various airborne transmission solution in use today and assessing future resiliency after COVID-19. Now, Engineer Chen is a familiar face. We well known in Malaysia. I think even though I don't wish to introduce, but for the participants from 8 other countries, I want to go through his biodata. Engineer Chen Tiam Leong, fondly known as Engineer T.L. Chen, is the past president of the Associations of Consulting Engineers Malaysia, ASEM, the Institutions of Fire Engineers Malaysia, IFEM, and obviously the Malaysian chapter of ASHRAE. He's also the honorary life advisor to the Malaysian Air Conditioning and Refrigeration Association, MASHRAE, and advisor to the Building Automation System Associations of Malaysia, BASAM. Chen is a practicing consulting engineer based in Kuala Lumpur, and his design has won ASEAN Engineer Awards, Emerson Cup, and ASHRAE Technology Awards. Engineer Chen lectured globally on the subjects of sustainability and energy efficiency under the ASHRAE Distinguished Lecturer Program, and also specializes in energy and fire and life safety audits. He's involved in the development of the numerous Malaysian standards, including the famous one that we use, MS 1525 on energy efficiency, and he has authored and co-authored many technical papers, articles, which are regularly featured in a technical publication. He is also a qualified HRDF trainer in recognition of Engineer Chen's contributions to the engineering fraternity. Engineer Chen was honored with the ACEM Gold Medal Awards in 2010. Without much ado, Engineer Chen, the floor is yours. Thank you.
Thank you for a very generous and kind comment. Okay, my paper will be titled A Critical Review of the Effectiveness or Otherwise of the Various Airborne Transmission Solutions in use today. And we'll go on to assess the future resiliency after COVID-19 of all these technologies. And it's a good follow-up to the first paper where a lot of introductions were made. So some of them may overlap slightly, but I'd like to skim through very quickly. Let's recap. We had our first webinar on IAQ at the peak of the pandemic in August 2021. At that time, MASHRAE decided to come up with this webinar 1.0 to critically evaluate all the various market products and technologies that claim to contribute to IAQ improvements. And you can rest assured, everybody's into the game. So we wanted to make sure that the layman understands all these issues, including even the professionals. And arising from the need to respond promptly to the numerous questions posted after that webinar, MASHRAE set up a local chapter Epidemic Task Force to mirror that of the society's task force. The task force went on to develop the MVC, which is an acronym for MASHRAE Ventilation Calculator. It's a software that's free on the website, which the third speaker will introduce and elaborate on. That was at the webinar 2.0, which was held about 6 months after the first webinar. And at the webinar 2.0, the speakers generally considered that COVID-19 will not be going away anytime soon, and it will linger on under the post-pandemic or endemic stage. And today we are actually, or at least for Malaysia, we are in the transition stage to the endemic era. We haven't reached it yet because the government will announce the decision by the end of this month, 30th of June, whether we have reached the endemic era or still in the transition stage. So as today we learn to cope with airborne transmissions, we continue to explore optimal solutions for various items, and especially related to IAQ. And this paper will resume a critical review of the various technologies promulgated and entrenched in the market since the heydays of the pandemic. So let's examine it. Let's start by looking at the list of prevalent entrenched technologies at the height of COVID-19 during our fight against this airborne transmission. Remember, I'm only concentrating on airborne transmission, not surface transmission, etc. And first on the list of this entrenched technology, it's actually not new. Obviously, good filtration is what Dr. King has mentioned. We are all moved on. Many of us have moved on to MERV 13 filters or even MERV 14 or right down to EPAR. And if you've not seen any one of them, this is a very quick snapshot of what these filters look like, and also the definition of why MERV 13. You can look at MERV 13's quality that it can capture particles down to 0.3 to 1 micron size with efficiency of 5% and over 90% for those larger particles. And if you move down the line, from MERV 13 to 14 and so on, you saw the earlier curve, it plateaus off, so there's no very little advantage, extra advantage gain, but you pay more. And unless you want to go all the way to MERV 17 and above, that is the HEPA range, which obviously has the high performance up to even 19, we call it 99.999 or 497. Next, entrenched technology, yes, plenty of brands now, the portable air purifiers. And you can see in all shapes and sizes. And the challenge has always been, what's the efficacy? And as Dr. King also highlighted, a lot of these do not only have a good quality air filters from PPAR, they also have additional other technologies incorporated into it. What's the third item? Generally, in this particular case, I talk about general ionization air filtration. There are plenty, many types inside there, but many are beginning to get entrenched in industry. Designers are beginning to put it in. And one example would be transportation. And the fourth item will be another specific ionization technology. That's the electronic filters, more commonly known as electrostatic precipitation air filters. Again, it's not new. In fact, the first large-scale installation of these ESP filters was done in the building here. If those of us who are familiar with the Energy Security Commission's building, and ESP is very good at filtering, especially smoke particles and so on. And it was already on the large-scale application back in 1999. At the time, the country suffered a lot of haze from the Borneo fires. And this building actually was one of the rare buildings that was very clean indoors. What about the fifth one? The fifth technology, UVGI for HVAC AC system using the UV lamp. And the various examples already highlighted by Dr. King. And this has a lot of players in the industry now, very well accepted. The sixth one will be the upper room UVC. Again, not a new technology. This technology proved itself even during the TB outbreak days. That's a long time back. So now it's becoming more popular because it does disinfect the zone better. That's exposed to it. And the final one will be ozonation. We call it control ozone. And one particular technology called subfusion, which the last two speakers will elaborate on. And this is one that we have quite a bit of emphasis in this particular webinar. Is because, not because it's a homegrown technology, but because we were very stringent, or the committee, even the ETF committee was very stringent on it until it had all the proven tests and so on. So, and I will try to elaborate some of this that went through. So an example of it will be an application even in the retail outlet, retail mall with the food and so on. Okay, what about a list of non-entrenched technologies to combat airborne transmission? Yes, the 7 are listed. In my opinion, they're quite entrenched in the local market now, or at least in this part of the region. What about other technology, which Dr. Ken also highlighted? There's a whole lot of them, and I'll just generally summarize 8 of them in the general list here. Atomized air disinfectant, including atomized biohook formulation, gas-phase air cleaners, combination air cleaning system, photocatalytic oxidation, dry hydrogen peroxide, vaporized hydrogen peroxide, ionization with various types of bipolar, coronal discharge, needle point, reactive oxygen cleaners, and even pulse xenon lamps of far ultraviolet devices and so on. So there's plenty of them in the market, but what I would classify as not entrenched. Yes, there are specific applications. There are certain people who prefer this, but a word of caution that Dr. King has highlighted: make sure they have a sound basis, sound science, and so on behind it. Okay, let's see what's next. I hope my slide's not hanging. It looks like it's been hanging. Okay, sorry. Okay, and this has been highlighted. I think I won't elaborate any further on that CADR. It's very important to understand CADR efficacy to determine value for money between different technologies and even between different brands of the same technology. Next, I'll touch on complementary to air dissolution, the system design solution. You talk about technologies, the devices, and so on, but a lot of application on a larger scale has to do with design solutions and integrated system design solutions. And when we talk about airborne transmission, we talk about overhead air distribution air conditioning, which all of you are very familiar with, which is very common. Maybe 90% of installations are done that way. What are the pros and cons? Because of time constraint, I won't elaborate on all these things, but for those who are interested, you can read up, or you can even access webinar 2.0. I think the slides are still there. What are the options? Underfloor air distribution effectiveness. Is it better or worse or no difference? So obviously, there's a single directional flow. Then we tell you that yes, there are maybe more pros than cons here. And the third and last one will be thermal displacement ventilation, PDV. Locally, we call it low-level displacement. That was because when it was first introduced locally, again back in as far back as 1995, when we designed some was designed it locally, there was no such thing as TDV, so we invented our own words called LLD. Fundamentally, it's the same as UFAD, just that one is for comfort cooling, one is for transient cooling. So you can see that yes, the air is coming from the low level and extracted at high level. So these are the complementary solutions we'll talk about. I would like to re-emphasize or remind everyone, especially designers and those who are very familiar, on the elements, the key elements when addressing airborne and non-airborne transmission. Okay, you have to understand the effects of all these particular factors. The effect of air movement, air replacement, ventilation rate, recirculated air, air flushing, air stagnation, temperature, and humidity. And hopefully, the various terminologies are clearly understood by now, especially air change per hour, ACH, versus ventilation rate, which are often confused even by the practitioners. So I hope we get this right. And also, and to emphasize the importance of air movement, temperature, and humidity in our climatic zone. I know there are overseas guests. Our climatic zone means our equatorial tropical zone. As compared with the 4-season climate zone, need to be understanding clearly, including applications, because while it works in a 4-season climate, not necessarily will work here. So there must be modification or tweaking or refining to get it right. So pertaining to increase of ventilation rates and indoor testing parameters even. And while we now are certain to progress to mitigate airborne transmission for the endemic era, we must and should not forget to concurrently address climate change issues, which touches on energy penalties, energy efficiency, even energy resources. So we can't decouple this. We have to remember that. Now, I purposely put up this slide, this gory looking slide, just to continuously remind ourselves that no amount of fantastic technology or devices can solve all your problems if your basic fundamental practice is not done properly. I'm sure you've seen this. So the answer is, forget it. If it's done this way, it will never work. Right? There are good examples and at the left and bottom, yes, that's the way we do it. So I won't elaborate on the thoughts on this, but just to move on. This table, verification of IAQ technologies. And I must qualify here that that is my own personal evaluation. It's going to be very challenging, but I don't have time to elaborate on why I assess it that way, except to give you a tabulated final result that I believe I can be as neutral as possible. Now, what I'm looking for, I'm going to start off with again on the 11th column, the 7 entrenched technologies, and what are the issues we look at, whether these technologies they have sound science backing them, whether they are scientifically proven. The next one is the R&D results. There's sufficient R&D results to establish what the intention is. Third-party tests. Now, there's a lot of difference between this column and the next column. Third-party tests means have they undergone third-party tests? And most of these third-party tests in this column would refer to third-party laboratory tests or recognized lab tests that are conducted because they're paid by the manufacturer of this technology or sponsored by the manufacturer. Then the next column on independent third-party verification. what's so different about this compared to third-party test? This one is for also recognized labs, very recognized labs doing this testing independently. They are not sponsored and whatnot. They selected all this technology to test independently and come up with results. And this is more exciting and more proven if it really works, because these are neutral people, not picked for. And then the next column be on proven applications. Yes, typical engineers, whatever product can do this, can do that. Give me the statistics, the data, the actual working model, the actual results that you get at the site, at the real installation. This is called proven application. And finally, inevitably, energy penalty. What are energy penalty? Okay, and here are the results that I've come up with. And I just run through and elaborate a bit. The more ticks means the better. The more crosses means the worse. Look at the filters, the MERS 13 and HEPA. Of course, it sounds established way long time back. So it's 3 ticks, the maximum 3 ticks. R&D also the maximum 3 ticks. Third-party test maximum. Independent verification always there. Proven applications plenty around, no doubt about it. But high penalty, energy penalty, because the increase in static, the fan power have to increase. So we pay for the penalty. But even then, we pay for the penalty is still even less than if you bring in more outside air, that aircon window has to increase. So yes, it's still a balance between that. The next one, portable air purifier. 3 ticks, the sound, it seems after all, most of them are with HEPA filters. 3 ticks for R&D, 3 ticks for third-party test, but third-party evaluation because of the efficacy and whatnot. Yeah, not really a single tick, and the proven application single tick because they are very localized, and also the rating. And penalty, yes, lesser than the MERS filters, because as you know, because this is now ventilation at source, so at least you don't push air throughout the whole system as in a very common ducting system. So it's 2.5 process. Ionization in general, the science is 3 ticks. R&D results 2, not as well established. Third-party test, yes, when they test it, most of them get it verified. Independent party test, just a single tick. Proven application, single tick. Energy penalty is also there, not as much, not as high, 1.5x. ESP filters, 3. Independent 2, and there's penalty 2 crosses. UVGI, 3 all the way. Independent 2 and 2, and that's also penalty of 1.5x. Upper room UV, yes, triple all the way. Independent test 2 ticks and 2 ticks, and energy penalty, yes, at least there's still energy penalty, single cross. Ionization, there's controlled ionization in this case, fusion, 3 ticks all the way. In fact, I think the subsequent speakers will lend credence to why I rated it that way, because we are very stringent about it, unfortunately, especially when it's a Malaysian technology, right? We want all sorts of battery or test and so on before we are satisfied. And an energy penalty is a very good, it's only a 0.5x because that's the lowest energy. So that's my verification, I qualify again, my personal verification. It's challenging. I have reasons for doing that, but not enough sufficient time to elaborate on it. Next, I'd like to touch on the recommended enhancement technologies during pandemic. Under webinar 2.0, I put up this table, and it says 6 categories of a recommendation. 1 being we should have it, 2 good to have, 3 optional, 4 luxury to have, 5 overkill, 6 no need or not practical, and asterisk denoting yes, even if you apply that, it should be targeted localized areas. And again, for the 7 technologies to talk about, and in this particular case, I must apologize here that it's not in the order previously, but all of them are here, so you can see how it was presented in the webinar 2.0. Just running through the upper room UVC for home, yes, it's an overkill because houses normally the ceiling heights are not not that high. I'm talking about typical houses. Of course, it's within a house where you incorporate a huge function area and so on. Yes, it's applicable, but I'm talking about typical ones. Then even short lot office, again, low ceiling height and so on. It's optional to have office. Yes, it's good to have during the pandemic. It's good. And the more, but more targeted areas, not everywhere, not any low ceiling height retail, but maybe the public areas is very effective. Healthcare, and at the time I said, yes, you should have, but targeted areas. Industrial settings, yes, there's no need. In the process area itself, or maybe certain high volume labor areas. UVGI, you can see what I've given. So all these are repeat of what I've shown before in webinar 2, but what has changed since then? Okay, let's look at it. What has changed? Post-pandemic IAQ recommendation, now transiting to the endemic. Same 7 technologies. What is my latest recommendation? Well, we don't talk about recommended ventilation rate because it's higher. I said that. No, we still talk about there must be minimum ventilation rate. And then, yes, I think Dr. Kim used the word equivalent ventilation rate. So now, yes, you have minimum, but now you're complemented by other technologies to achieve the equivalent requirement. So your UVC, so have I changed anything for the home? I said no. Now we don't really need to have UVC upper room, maybe there's no necessity. Shop lot office, depending on your height, right? There still is an overkill. Office, it's a luxury to have more. Yes, also targeted areas optional. Healthcare remains the same. Industry, we downgrade a bit more. UVGI, no, we'll not change anything except for healthcare. And healthcare used to be, you should have it, but now maybe it's good to have. Okay, MERV 13, no change at all. HEPA also no change. Portable air purifier, yes, everybody's rushing to buy it because there's so much outbreak around. At that time, we said that yes, it is optional, but today I will say that it's luxury to have, and then all the way it's luxury to have. Then, if you want it, it still has advantage, but for luxury, there are many ways of skinning the cat right now. And this endemic era, ionization, basically no change. And the last one is on the control ozone fusion. Used to be all optional. Now with the proven technology, as we move on, I said yes, it's good to have. So in every step of it, I've upgraded it to be good to have, and so on all the way. Sorry, the slide is not moving, so I'm trying to. It says here the screen is paused, so I don't know what happened here. I beg your pardon, man.
So, Engineer Chen, you want the secretary to share the screen for your remaining slides, or how?
No, let me just address it. I think I can. Okay, I resume sharing it. Now I'll just play with it. I apologize again. I'll just go through it very quickly. Back to yes, it's moving again. So here, yes, now it's good to have. Right. Oh, that's it. I finished. Okay, thank you very much.
Thank you very much to Engineer Chen Leong for the very insightful sharing. I'm sure all of us have benefited from the sharing on the prevailing technologies during the height of the COVID-19 to combat the pandemic, and also especially the elements for the designer to design for airborne and non-airborne transmission, and more importantly, your personal verifications of 7 IAQ technologies against the 6th sector, which is extremely useful for all of us. Thank you again for those participants. If you got questions for Engineer Chen, please key into your chat box, and we will answer all the questions during the Q&A sessions. Thank you, Engineer Chen. Now we go to the third speaker, who is none other than a very prominent engineer, Engineer Ao Chong Han, who is going to share with us the topic on the MASHRAE MVC software tool and air quality measurement protocol. Now, Engineer Ao is the Managing Director of Primetech Engineers in Berhad, and he holds an honors degree in mechanical engineering from University of Malaysia. And obviously, he has diverse experience in a wide range of projects and has successfully led the implementations of a sustainable strategy for GBI and GBI Platinum and Gold buildings. His project portfolio includes the country's tallest skyscraper, Exchange 106 in Tun Razak Exchange. And in the year 2020 to 2021, 3 of his projects were awarded with 5 National Energy Awards, 4 ASEAN Energy Awards, and the Golden Pencil Awards of Media International HVAC Design Contest. So Engineer Ao lectures regularly for various NGOs and universities on topics related to M&E design, sustainable energy, energy efficiency, and fire safety design. He serves as a working group member for various Malaysian standards, including UBBL 1984 Amendment 2021 and the MASHRAE Ventilation Calculator. Without much ado, Engineer Ao, the floor is yours. Thank you.
Thank you very much, Engineer Ong, for the kind introduction. Yeah, I'll move in straight to my slides. MASHRAE Ventilation Calculator and Air Quality Measurement Protocols. AirStraight Malaysia launched this MVC in January 2022, okay? And then after the webinar 2.0, and we have already introduced some of the basic concepts to it. Today, we will actually repeat it so that it can be used for those who are new to this software. It's actually an Excel-based software. So the first part I'll be talking about MVC, and the second part I'll talk about the ASHRAE recent standards and how the MVC can still be used or need minor updating in the future. And then, of course, the last part of it will be about measuring and computing time-weighted average on how we should monitor indoor air quality, especially on concerned contaminants, or we call it different type of particles in the air. Okay, this background of MVC is actually based on a few important guidelines. The first one is in terms of our local guidelines, the one for the healthcare by KKM, and the other one, the DOSH guidelines on indoor air quality during pandemic, COVID-19 pandemic. Okay, and then for airborne transmission, okay, HVAC engineering mitigation control for COVID-19 aerosol transmission, there are basically 3 major strategies. The first one is by dilution. That's how we use outdoor air to actually dilute the amount or the concentration of virus as the infected person breathe it into the space. And of course, the second one is what we are familiar with, filtration. Is actually entrapment. We actually trap the virus on the filters. That's why the efficiency of filters are important. And the third one is what we call sterilization. We deactivate the pathogen either by UV or by other technologies. So basically, the MVC is based on these 3 major principles. Okay, of course, this is taken from the ventilation guidelines from Kementerian Kesihatan. Basically, it mentioned about filters, it mentioned about CADR, it mentioned about the famous 10 liters per second. And of course, those guidelines for non-centralized aircon, you talk about portable air cleaners, also CADR, and a combination concept where you cannot achieve the CADR, and then or the combined effect must reach 10 liters per second. So the concept of equivalent ventilation has already been prevalent, even at the early stages, or we call it at the peak stage of the pandemic. We know we need a lot of this external air or external outdoor air. We need a lot of dilution, but where we cannot achieve the type of dilution, we need to have other measures. So either we increase our ventilation. If not, we use portable air purifier. That was the concept. So there's a concept of a common metric, equivalent outdoor air or equivalent ventilation concept. Of course, the 10 liter per second is actually computed from what we known as the formula that actually has indication of risk according to the time of exposure and as well as the occupant and the outdoor air. That is the basis of how people get a 10 liter per second. Of course, also depending on the virus type of mutation and the spread rate and all that. So from there, we actually summarize into the amount of fresh air that we need. Okay. MOH setting, same thing. Talks about 12 air change per hour. 12 air change per hour is actually related to the outdoor air as well. It's just that it's being explained in terms of the room volume change. Okay, the room size as a standard to compute the outdoor air required. So you have existing outdoor air provision, the equivalent outdoor air from filtration. Okay. If you cannot dilute, then you clean it, you trap the virus, you add these both together. If you still don't have enough, then you need to add portable air purifiers. That's why we see some COVID wards has portable air purifiers inside, because they use this formula to compute the actual 12 air change that is required. Okay, and then there's this building readiness recommendation from MASHRAE at the peak of the pandemic, which actually uses a concept of flushing. The equivalent outdoor air is used for flushing. The same thing, if you have outdoor air, you have certain outdoor air, you have return air, and then whichever, if you minus the outdoor air from the recirculating air, and then after the filter, whatever is left over, you add on the efficiency of the UVC filter on the air. That's how you actually have this concept of common metric as well to come out with equivalent outdoor air to flush the building. That was the original intention of the building readiness method. Then how do we evaluate the filtration efficiency? So in the same series of information, they used the influenza A distribution of virus in terms of particle size, because the virus may be small, 0.3 micrometer, but a lot of time it is attached to dust or even when people sneeze, their saliva, this human byproduct that comes out, breathing material, breath, whatever we exhale from our nose, and then of course some of the dust, some of the particles. That's why you have different distribution, and we realize that 50% of the virus pathogen can be in this range, 3 micrometer to 10 micrometer. Of course, you have virus seldom occur in pure virus form, so that's why you have a distribution, and you allow this distribution. Compare it against the capture efficiency of each filters. That's why we come out with this type of average, and we use this average to actually put inside the MVC software. Okay, so as a conclusion, you can have different strategies, a minimum ventilation provision. No amount of filtration can actually totally replace ventilation. That's why we encourage people to have a minimum prescriptive bylaw requirement. And then you add on with additional ventilation or purely portable air purifier or UVC or so on and so forth. So the MVC have this strategy concept in mind that what is the minimum ventilation you can provide? What are the portable air purifiers quantity that you are providing? So you add up this, where do you stand in comparison to the 10 liter per second? So as a summary, this is how it looks like. Liter per second or ACH, then a yes or no. So we have in mind the more lay people, not so much on the designers. Designers, they can anytime put up a spreadsheet, but we think about people with split units, with small restaurants, shop lot offices. These are the people that they will be concerned. If I want to buy a portable air purifier, how big of a capacity should I buy? So this MVC, we have that type of users in mind. Okay. before I go further, I want to we realize there's a lot of questions asking what is actually 10 liter per second and what is actually ACH. Okay, how are they related? They are actually related. Okay, basically ACH is air change per hour. Okay, air change per hour means the amount of air that is being changed in 1 hour. How many times of the volume of the space is being replaced in 1 hour. That's what you mean by air change per hour of outdoor air. Okay, liter per second basically mean how many people in the room multiply by the required liter per second. Is actually the flow rate, how you introduce the flow rate into the space, liter per second. So if you have a space 6 meter, 5 meter, and 3 meter, you will have 90 meter cube. Okay, one air change means 90 meter cube per hour. Okay, 12 air change means 90 meter cube times 12 per hour. Okay, let's say you have four person, and the requirement require you to have 10 liter per second per person. That's how you come out with 10 times 4 equals to 40 liter per second. Then you have a conversion. 40 liter per second is actually 144 meter cube per hour. But if you compute based on air change per hour, then basically 144 meter cube per hour divided by the space volume, the fresh air you are providing is actually 1.6 air change per hour. So if you understand, air change per hour and outdoor air rate, they are interrelated. Okay, if you still cannot compute by yourself, use the MVC. That is, you key in the dimension, you key in your required fresh air, you come out the ACH as well as the direct outdoor air or the equivalent outdoor air that's being provided. Okay, so where do you get the MVC? You download here. You can, if you have the slides here or you're on your screen, you take out your phone, you can scan this QR code, you bring you directly to this website. There's this red line here, and there's another Google Drive here. You press it in, you can find there are a lot of materials there. All the slides for the webinar 2.0 plus the MVC is actually an Excel software you can download there. There's all this introduction, you study this, all the links, all the basis of computation that come up with the MVC, they're all here. You can read it. And then this is how it looks like. Okay. You have centralized air handling unit and plus other strategies. That's why you see you can add up all the strategies to give you an equivalent ventilation. Okay. Okay, so basically it's a yes or no. You come out with how many liter per second. Depending on your room's volume, you give you the air change per hour of your outdoor air. Okay, so basically you can use this. You can refer back to these slides at the end of this seminar. Okay, then I want to do a small comparison, a quick comparison with this draft standard. So we have not updated the MVC because this is still a draft standard for public review, actually published by MASHRAE. The name of this standard is Control of Infectious Aerosol. This standard uses the term equivalent outdoor air. Like I mentioned just previously, the equivalent outdoor air is actually used to actually flush the building, but now it's actually used as a benchmark figure for the outdoor air requirement. And if you see, previously we all talk about 10 liter per second. Now there are different liter per second. But of course, if you use the MVC, you can just key in here. If you want to design for gym 40 liter per second, you actually can key in here. And we actually use this outdoor air rate per person. It's an equivalent outdoor air. The MVC use an equivalent ventilation. So basically, these are all interchangeable terms even before the pandemic. Okay, and then of course the formulas, they give a lot of formulas. Basically, the main difference is the CIA, the Control Infectious Aerosol, this standard is basically following the route of the air. That means the AHU air, it goes to the space. Then when you come back as return air, you add with fresh air. When your air reach the space, there's portable air purifier, how you deduct all this flow rate out. So basically, the designer will be very familiar with this, okay? But this MVC is based on strategies. So if you have different strategy, you add up the equivalent outdoor air of each strategy. But when you come to AHU, of course, we follow the same format because we actually minus off. Because when you UVC a filtered air and you provide UV without the filter, of course the efficiency is different. You need to minus out the flow rate that goes through the filter multiplied by the efficiency. So basically, this is all arithmetic. If you follow the air path, then of course, it's a more systematic for the designer. But if it's a layperson style, the MVC is still very useful. Okay. Then you have this pathogen removal efficiency, same concept, distribution of virus multiplied by the efficiency is a weighted average concept as well, to give you a percentage. So basically you can compare these two percentage and you can select the next rating. Although this particular standard has not actually tell us what type of distribution based on which virus that actually come out of this weightage. Maybe in the actual revision, they will come up with the basis of this computation. Air cleaning, okay. It is interesting to note that the CIA actually has lumped everything into air cleaning, indoor air, in-room air cleaning, there's portable air purifier, in duct air cleaning, there's actually UVC and filter, and air cleaning that distribute anti-micro agents in room air. That's why I think that 7.5 is basically used for, let's say, for example, ionization or sterilize this control ozone sterilization. But unfortunately, this whole section 7.5, there's no information. It's reserved for future use. So this is actually one of the reasons why I come out with MVC is because of this. Because how do we quantify the effect of control ozone or ionization in comparison to portable air purifier? That was the underlying question. That's how we come up with a common metric concept. So basically, under air cleaning, they still have the same concept of equivalent outdoor air, but this whole 7.5 section is actually left blank. So we still do not know how long we would need to actually come up with this common metric, but we are moving at the same direction. Okay. Then the next part I want to talk about in this paper is about considerations when we use control O3 sterilizers or control ozone sterilizers. They are not to be used with activated carbon filter. Just now you mentioned, Dr. King mentioned about these gas phase filters. A lot of them has activated carbon. Some has potassium permanganate as a gas phase filtration. It takes out odors and all that. But then if you have activated carbon, it will actually absorb the ozones in the space. Okay. And then of course there's a second this consideration on the limits of ozone in the space. The main reason is because when we talk about filtration units, we talk about portable air purifiers, the UL standard, the standard to actually evaluate portable air purifiers is very stringent because they do not want ozone as byproduct, because ozone can come uncontrolled. Uncontrolled ozone can be a byproduct of the UV lamps that are in the portable air purifier. So there is actually a confusion between uncontrolled ozone and controlled ozone. Uncontrolled ozone would actually be a byproduct of the portable air purifier. That's why there's very stringent standard to test the portable air purifier. But when we have controlled ozone, then we also want to ask ourselves, what are the safety limits so that we actually can deactivate the pathogen, but at the same time, it is safe for human use. So basically, these are all the standards. If you look at it, OSHA has a 0.18 hour time weighted average. Malaysia DOS has an 8-hour time weighted average of 0.05 ppm parts per million. How do we go about measuring this? Okay, this is the main question of this section. Time weighted average is actually the employee's average airborne exposure in any 8-hour work shift, okay, of a 40-hour work. Basically, it is concerned if the people working in the space is exposed 8 hours a day for 40 hours, that's the normal working hour. What is the limit? That is the limit. It's a time weighted limit. Okay, so basically it's actually a weighted average concept. And there is actually a sampling strategy, okay, inside this Industry Code of Practice on Indoor Air Quality 2010 by JKKP. And depending on the floor area, there are a number of sampling points, and there are all these guidelines to follow. So if I take an example of an office layout, 4,007 square feet, ceiling height, and then we have 2 points with a control ozone sterilizer, 10 nozzles, because it's control ozone, there's a monitoring system. Then we measure the ozone inlet, okay, 100 cm from the floor. Then we take one set of data for a duration of 8 hours. Okay, then hour number 1 is 0, hour number 1, 0.043. So you see that actually the ozone level is different at different hours. So why do we need a time weighted average to calculate the weighted average of this distribution? So if you include in the time weighted average, you add up all, then divide by 8 because it's taken over 8 hours. So you realize that although there are some points which are more than 0.05 and some points below 0.05, the time weighted average is actually below 0.05. Okay, so it's very important that we do not carry any sensor, go to somewhere, then turn out my sensor. You may be visiting this maybe a coffee shop at 10, 11 a.m. You get a 0.07. Then you start declare to your social media, say that, oh, this place is unsafe because the ozone level is very high. It's not a fair, it's not a correct measurement. Okay, because we need a time weighted average method. So the right way to do is to set up air monitoring station there to actually get the real time weighted average. Because when you control, you need to be sure that you have sufficient concentration to activate the pathogen. That's what we want to achieve. Same thing. Okay. Okay, so basically, the summary of my paper today. Of course, the MVC tool is actually useful for computation and comparison of total ventilation of various strategies. We are actually going towards this direction, a common metric, climate change concern, and now, of course, there will be some time for us to actually stabilize on how many liters per second is actually required for different setting. There will be continued discussion, and this MVC tool actually, if you use it, you will be able to assess at least that is our intention for the layman to actually do a comparison between different available technologies, but the market also need to come out with different ways of computing or on a common metric, so that this concept of equivalent CADR can be readily achieved. I mean, can be easily understood by the users, so that different technologies can be compared. Maybe the cost, maybe the effect, the usefulness, and the TWA method in lieu of spot reading provides a more comprehensive assessment of the risk of exposure to chemical contaminants, if any. Okay. Yeah, that's the end of my paper. Thank you very much.
Yeah, thank you very much, Engineer Al, for the very interesting sharing of the MASHRAE MVC software and tool. More importantly, also on the method on the time average, time weighted average kind of method, which is very important for us to take note. And of course, the various definitions, the way to do the equivalent ventilation is something I think all the designer and practitioner need to take note. Thank you very much, Engineer Al, for the very interesting sharing. Now we are into 3:30 right now. We are 10 minutes behind time. I think we should be able to catch up, but I would like to take the break of 10 minutes for we call a bio break, so that we will come back. All the participants and this webinar will continue at 3:40. And when at 3:40, we'll have these eminent speakers from Germany. Professor Grün will be sharing with us his very important topics. So before all of you go for your break, please type in your questions into the chat box, so that we're able to get a panel of speakers to respond to your queries during the Q&A sessions. Okay, looking forward to see all of you at 3:40 p.m. short while. Thank you. Bye for now. Hi, welcome back to all the participants all over the world. Good afternoon to all of you. And due to the interest of time, and also our next speaker, Professor Grün from Germany, he has other commitment. So we'd like to continue with the presentation. Now, the fourth speaker is Professor Grün from Germany. Good morning to you, Professor Grün. And
good morning. Hello.
Yeah, good morning. So Professor Grün going to share with us the results of viral load reduction using ventilation with other technologies. So I would like to introduce Professor Grün. He's the Deputy Director of Fraunhofer Institute of Building Physics, IABP, in Germany. And this Fraunhofer Institute is a research institution that specializes in the field of building physics and conduct research and development on areas such as energy efficiency, air quality, acoustic, and building material that aims to improve the performance, safety, and sustainability of buildings. At Fraunhofer, Professor Grün worked closely with industrial partners as well as politicians. That's interesting. To develop solutions and framework conditions for healthy and energy efficient buildings, especially in the context of renovation. His work is application oriented, and he seeks to have an influence on the current and future way of construction with his research in building physics. Professor Grün has been heading the Department of Engineering Efficiency and Indoor Climate from 2015 till 2019. He's also the spokesman for the Fraunhofer Building Innovation Alliance since 2022. He spent over 14 years in various research and management positions in the Fraunhofer Institute for Building Physics, IABP. Professor Grün aims to disseminate his research result not only to the public but also in education. In 2019, he returned to his former university in Stuttgart, where he studied civil engineering and has been lecturing on building physics ever since. Professor Dr. Gunnar Grün holds a PhD, Doctor of Engineering from University of Stuttgart, Germany. Very impressive credential. And good morning to Professor Grün. Thank you for joining us as a speaker. And now the floor is yours.
Yes, thank you, Engineer Owen, for this kind introduction. And also thank you all of you to can have the possibility to present our results from our research. And I want to talk today about the results of some experiments we've done for viral load reduction during the pandemic using ventilation with other technologies. Maybe a very brief introduction why we are good to do this. The Fraunhofer Institute of Building Physics, here you see a small map of Germany. We are located in the southern part of Germany. One part is in Stuttgart, in the city of Stuttgart. We are also affiliated with the university, and the other part is in Holzkirchen, which is south of Munich, and where we also have large testing facilities you see here. And in building physics in Germany, what are part of building physics? We have several competencies. As you may know, in building physics, we deal a lot with acoustics, we deal a lot with energy efficiency, hygrothermics, heat and moisture transport, things like that. But we also look at life cycle engineering and at hygiene, air quality. So we have two large departments. One is indoor climate and energy efficiency, and the other is environment, hygiene, and sensory, which have the competencies why we dealt with all these ventilation issues in the indoor climate part and the reduction of microbiological growth, in this term viral load, in our institute. These are the two competencies which came together during the pandemic. And we looked at first at the general characteristics of the viruses. And I just want to recover this again, why this is important. Yeah? A virus in itself is not an independent metabolism. Yeah? It needs a host bacterium or cell where it multiplies, for example, our body. Yeah. It has a certain program to multiply and spread. It has a DNA or it has an RNA, yeah, so some genome, which is also the case for the coronavirus. Yeah. And it has a certain structure, which is also important. It has a certain size. We heard a lot of filtration and other things today, and the coronavirus has a size of 100 nanometers. And important, it has a single-stranded RNA, which is drawn here in the picture. And then it has a shell, and this shell has spikes. And as soon as you destroy the virus in certain terms, yeah, in either the RNA, so it cannot multiply, or the shell or the spikes, so it cannot trigger to the host bacterium or cell. And then you can avoid the reproduction of this virus, and it is stopped in its multiplication. That's important to remember. So we first looked at what could be a surrogate. So a master virus which is not impairing our health, so that we can test with the virus. And we looked for the 5-6 bacteriophage, which is a very unusual bacteriophage. Most likely you hear bacteriophages with other drawings. But this bacteriophage, the 5-6, is an uncritical model virus, which also has a shell and which also has RNA strands. This is why we selected that one to go into the laboratory to look how we can have aerosol spread of viruses. Yeah, it's non-human pathogenic. It's on biosafety level 1, so you can work with it in each environment as long as you control it. It is enveloped, has a mean particle size which is a bit smaller than corona, but similar size. It has preferred room temperature and humidity, and it's a 3-stranded RNA virus. So very suitable to be a model virus for corona. And we knew since March 2020 that corona is mostly aerosol spread. So since that time point, we looked at how can we aerosolize the 5-6 and look at the aerosol spread. Why are we able to do that? Because we have also large laboratories where we have a very clean environment, where we can change the airflow, yeah, the so-called air test center, the indoor air test center, IATC, we call it. It's a unique facility we have in our laboratories. There we tested the nebulization of the corona surrogate viruses. We had all the online sensors and detectors which you will need, particle counters, ozone and NOx analyzers, TVOC analyzers. We can very detailed do the air sampling in these chambers for VOCs, all the byproducts you may have, and also even the airborne germs. So we investigated also how to collect this virus once it is aerosolized, so that we can recultivate it and look how it is again growing, if it's still multiplying after being collected. This we did with so-called plug assay tests. With a host cell, as you remember, the virus always needs a bacterium or other cells to grow again, which we did with Pseudomonas in this case. Second part why we were able to do this experiments, which I will present you, is that we also have a very good zonal simulation suite, where we can look at the spread of viruses and other airborne particles in a very simple way, where we simply build up a room out of several volume models, which are connected with so-called airflow models. It's a, let's say, very rough CFD, but which is very quick in simulation. And this we also did for the well-known case, which was reported in literature, this model restaurant, where we had a virus case on this place, which spread, and we rebuilt it also with our simulation. And you saw then where all this virus would spread with the current ventilation system in that case. And we also tried certain things in the ventilation system so that we can avoid the spread of viruses, where you have a much cleaner air after if you have an airborne index patient. Yes, you see in this picture that ventilation makes a huge part to have clean environments, which we have also seen in the past presentations today. But important is, what is the case if you have lots of people in a room and you want to have an additional level of safety in that room against airborne spread of viruses? That was the question we did then also in the case of cinemas in Germany. You know, all the theaters which have lots of people, large volume of air, but the spread of viruses then is still person to person. And once it goes again into the ventilation system, it takes some time. So we initiated the research project, Indoor Air Hygiene Application of Air Purification Technologies in Cinema Theaters in the COVID-19 pandemic, so-called CINECOV, which was funded also by the German Beauftragte for Culture and Media, and where we looked experimentally in several cinemas. What was the question? Initial situation is that the coronavirus still could be transmitted via aerosols in the hall before they went into the ventilation system and could be cleaned. Yeah. So the effectiveness of air purification technologies in such event rooms where are many people and the effective radius of such cleaning technologies are unknown at that point in time. Yeah, and we need then to implement them safely and good into hygiene concepts for such theaters. So we investigated the effectiveness of such purification technologies, also simulated this, but that's not the topic of today, and developed a quick assessment tool based on our simulation. Yeah, so what could we do? We analyzed the suitability of air purification measures and developed these hygiene methods. So the objective then was, how is the effectiveness of room air purification in auditoriums and its effective radius? So you need to see the degradation rate of active viruses around an index patient. That remained to be proven. How far could a virus travel being still active to the next place in that cinema? That's the core question. Yeah. For that, to answer that question, we went into different cinemas. We did in situ investigations in 3 theaters. One was a cinema simply with a good ventilation, displacement ventilation, to see, is ventilation really it is important to show again that it is important. And then we went with 2 different technologies into other cinemas with mixing ventilation, a ventilation pattern which is not so good as displacement ventilation. Once with the active oxygen converter, we heard it today as well, and also one with the upper air UVC disinfection system. First case is the Neues Rex cinema with displacement ventilation. Displacement ventilation is when you, in the lower part, you see it, when you supply your air below the seats with a little lower temperature than the room air temperature, then it's heated by the person going up and is exhausted at the ceiling. Typically, then also the virus is transported up in the air to the exhaust. And this is also what we see. Yeah, the principle works in the areas which is directly supplied with fresh air very well. Yeah, for example, here at an index patient. Yeah, here sees one of our simulation cases. Air is supplied under the seat and is going up again. Where it works more critically, not so well in areas where it's not directly supplied under the seat. Yeah, typically this is the case in the first and the last row. These are areas where you have to watch out carefully. Yeah, and also the occupancy density has an influence on the CO2 concentration if you take CO2 measurements as index measurement for air quality. That's important to remember when you design your sensory placement, yeah, which we have seen in the presentation before mine as well. This is just to remember that ventilation pattern is an important issue to look at when you design a theater. Displacement ventilation works well, and then you also have typically clean air. But if you don't have a good ventilation system, you want to have additional measures. And we had 2 technologies where we looked at. One is we also mentioned them today. Principle of plasma ionization. What is happening there? Basically, you add energy, you know, in this case. Then you form ions, yeah, from hydrogenium or hydroxylium ions. Yeah, they also can be produced some ozone. We also heard that today, yeah, and other byproducts. Yeah, and these byproducts are, you have to look at them carefully. So typically, you have an energy, you form ions, and then you can create byproducts. That's an issue you have to look at. That's why you should look at them carefully, and that's also why it was mentioned today already, that you have to look to measure these products. Second principle is UVC purification, typically in short wavelength below 280 nanometers. You have to look at that you have it not available for human beings in that case, where you can harm your eyes or your skin, typically below 220 nanometers. Yeah. What happens if this UVC is in the room or comes to the virus? It typically disturbs or destroys the RNA or DNA of that microorganism. Yeah, you break off your RNA, and then it's damaged and it cannot be replicated again. That's what's happening basically. Again, UVC is also energy, and energy then again can form byproducts. So you have to look at the system that it doesn't form too many byproducts, and that the wavelength is in a good way. Typically, you have an surface treatment on the lamps so that they don't produce UVC in the wavelength where you have much of ozone, but you have to look at this before you apply them. So second case was we went into the Cinecov Cincinnati theater, which is a large theater, yeah, with approximately 400 seats. And we have a mixing ventilation there. So mixing ventilation was supplied from the top, was mixed in the room, and then was exhausted on the sides of this large theater. And you see this here. Supply was in the air, in the ceiling, exhaust on the sides of the theater. So you have a mixing ventilation pattern, which was then in this theater present. In this case, we worked with air purification with the active oxygen converter, which was doing is dosing in the ceiling of that theater. So we dosed into this active oxygen, which is also then forming some ozone in this case. That was the air purification technology, which we also heard today that it's a possible technology. And the question was, can we reduce the virus, the active virus within the theater, before it leaves, the air leaves the theater for cleaning? That was our sampling test setup. We set up lots of mannequins in this theaters so that we have the right thermal load and air plumes, which are produced in that theater. We also did our aerosol generator, where we supplied all these model viruses into the theater. And in the distance of 1.30 meters, we sampled the air with our collection technology to do the plug assay testing in the biological lab after testing. At the same time, we also sampled ions. We also sampled all the chemical sampling to look at the byproducts, particle counting to see at the small particles, and also ozone measurement to see whether we had too much ozone in that case. And then the test procedure, as you see on the right-hand side, we first spread all the 5-6 fakes into the room without any HVAC and cleaning working, so that we have a right high level of model viruses in the room. And then we switched on HVAC and the air sample and the air cleaning device. We did 2 tests, one without the air cleaning device and one with the air cleaning device. So we had scenario 1 without, scenario 2 with air cleaning, additional air cleaning. Only HVAC on in scenario 1, HVAC and air purification on in the second part. And at certain distances in time, we sampled also the air Yeah, you need some time to collect all the viruses on the sample technology. That's why you need a time, and there. So we also see a decay in that case. So what you see here, this graph just shows what you recover as particles. Yeah, you see left scenario 1, right scenario 2, and you also see how much particles were in the air. So you see in the first part that we built up particles because we didn't have HVAC on. Yeah. So we just spread particles, and then we switched HVAC on, and particle sizes are removed, yeah, because of dilution of the air. We also had that. The green part is the reference sampling. So we sampled right before switching off HVAC, and then we sampled 3 times after switching off, switching on HVAC and switching on HVAC and air purification. You see similar build up and decay of particles in both cases, which is clear, yeah, because the ventilation and the air cleaning by filters from the HVAC are not changed in both cases. So we have the same thing, but at the same time we purify here. So particles are still there, but the viruses may or may not be damaged in the second case. And that is what you see in the next slide. Here you see the black and the green bars are the recovery of corona surrogate viruses, which are still active. Yeah, so in the first case, before switching on and switching HVAC on, we have 100% viruses present in the air. And when we switched on HVAC, in the first case, we spread a bit because we mixed the air of the viruses, and then it was decreased, yeah, also in which just HVAC on because we dilute the air. When we switched also on the air purification, we were not able to find significant active viruses still in the air. So the viruses were destroyed, although being still present as particles, but not being as particles which were able to reproduce themselves as viruses. That's what the core message of that graph. So it was very successful to destroy the virus. Yeah, here you see all the volatile organic compounds we measured in both cases. Yeah, all the VOCs, VVOCs, etc., PP, all the different parts, formaldehyde, acetone, etc., which would be present in that case. And we didn't see a buildup of VOCs, SVOCs, or VVOCs in both cases. Yeah, we had very low levels of VOCs in both cases. So we didn't see a buildup due to the purification. However, still you have to look at it. Yeah. What was about ozone? Of course, we had ozone because the principle is building on active oxygenation. But we had an ozone level at that time of 120 micrograms per cubic meter, which were controlled by the system, yeah, which we have heard also in the presentation before, why we did select 120, because that was the level of safety in Germany at that time of experiment. Yeah. And also ions were not so many present. Most thing was the ozone that was working. TVOC are very similar in both cases, so not a problem in this case. So what we have seen, yeah, we were very successfully to inactivate the corona surrogate viruses in a distance of 1.30 meters, which is the typical distance in the cinema for the next seat. The dosage of ozone was adjusted so that we were at the target value of 120 micrograms. The addition of substances which are harmful is generally, you have to look at that, yeah, and the risk must be kept as small as possible, weighted against lower risk of other contaminations such as the virus itself. Yeah. So how high must the ozone concentration that we don't have it too high so that it's not critical? That was one question. And we didn't see the NOx concentrations going up. which you sometimes have when you look at ionizers, if they are not built properly. That's why we looked at that. TUVOC values were hygienically harmless. Yeah, but we still have to admit that we didn't have real persons in there. Yeah, so we didn't have the VOCs coming from persons themselves, just from the room and cleaning substances and so on. So we also did an additional test to look at byproducts. What if persons were present? Would that be critical? Yeah, so we did an additional laboratory investigation where we injected a VOC mix, which we created ourselves, yeah, of certain substances, which where we said, okay, that would be interesting to see whether ozone is doing something to these VOCs. And we had here an ozone production so that we had different levels of ozone in this laboratory room. And this is a very interesting investigation. So we looked whether we had a correlation to the buildup of byproducts by the level of ozone. Yeah, so we have a different ozone concentration, which we created in the laboratory. And with our VOC mix, the VOC fragrance, if you want to say, we have seen that there is, with, for example, nonanal, there's no correlation. So the R squared is very little. But with formaldehyde and acrolein, we saw a correlation. So we have a buildup of formaldehyde with increasing ozone. We have also built up of acrolein with increasing ozone if we have VOCs present from our mix. In our case, we were at 121 micrograms per cubic meter. That was our target value. And in this case, if you look at the typical occupational health and safety levels, here I took them from USA, you are below the critical values which are mentioned in there. Yeah, so we don't see a problem when using ozone at low levels, low and controlled levels. You can work with ozone. Yeah, but you have to monitor it, as mentioned in the presentation before mine. The second experiment we did is also how can we go lower than we were with ozone? And we did different experiments with lower levels of ozone, and we still see also a very quick build, at low levels of ozone, we still also see an inactivation of coronaviruses. So you can also work with lower levels of ozone than we worked. Yeah, for example, 0.05, as mentioned before, as the current target value, or in some countries, it's even lower, the target value of ozone. Still works to inactivate 5-6 bacteriophages and then also other microorganisms. Second experiment, or third experiment we did in the Trifthof, there we worked with upper air UVC, very similar setup. Yeah, we spread aerosols via the generator. We sampled it in 1.30 meter distance, had our mannequins there to build up the thermal plumes. We measured ions, ozone, particles, chemical sampling, as in the other cinema. Different, bit different air ventilation pattern in this cinema, because also mixing ventilation bath with these nozzles supplying the air. Oh, sorry. And very similar test procedure. Also 2 scenarios, one with HVAC on only, one with HVAC and purification. Here at the upper air UVC on. We dosed the 5-6 fakes firstly to build up the level, made the reference measurement, switched on HVAC or HVAC and purification, in this case upper air UVC, and did biosampling. So the same case. Here you see also the particle counts again, left-hand side scenario 1, right-hand side scenario 2 with air purification. Again, you see that the pattern of particles is very similar in both cases. Yeah, so after we switched on HVAC, particles are reduced. Yeah, the same in both experiments. But again, the question is, were the particles or the viruses being part of the particles inactivated? In this case, again. So here, same picture. You see also we have here also a reduction of of active viruses. This sampling 1 is the sampling before switching on. Black is the just HVAC. Again, we had a build-up of particles being spread by the ventilation pattern into the room, and then it reduced by dilution. And when we switched on the upper air UVC, we again had a very heavy reduction of viruses, active viruses, which could infect others when we use this additional air cleaning. So again, we had a very good effect of the additional air purification. In this case, not as quick as the other one, but very good still. Yeah. Why not as quick? Because the virus has to travel into the upper air part. Yeah. As soon as it is in the upper air part, it will be destroyed. But if it's still in the lower part of the room, it doesn't. The RNA is not damaged in that case. Yeah. So it has to travel once through the upper air UVC system. Formation of ozone, we don't have any difference to the reference case. Yeah, and of course the days are different because of the daily variance, but we didn't have a difference in ozone. We also didn't have a formation of TVOC and air ions. That was also not expected, but of course we measured it. So conclusion from these experiments, yeah, we can theaters operate hygienically and safely with state-of-the-art ventilation systems. That was also mentioned in the presentation before mine. If we have proper ventilation systems that works well, yeah, but if you don't maintain them, if they are not properly installed or very old, then they may have a problem. And then you might have to want to have additional measures for high hygiene standards. Then you can use additional air purification methods. And they proved also to be effective as shown in the last slides. So both tested methods, which I presented today, the active oxygen conversion and the upper air UVC, were able to inactivate aerosolized surrogate viruses within the typical distance of 1.30 meters around the index seat, significantly. Yeah, you have seen that in the black and green graphs. But in any case, you need to have an occupational health and safety standard that must be met by measurements, as we have also seen in the other presentation today. Yeah, and you must integrate this into your possible hygiene concepts of the venue. Yeah, that is different from country to country. And I'm very sure that you have also such standards in Malaysia, as we have it similarly in Germany. So that was my overview about the tested methods, and I'm very welcome to answer your questions later in the Q&A sections. Thank you very much.
Thank you, Professor Grün, for your very impressive sharing, especially the research on the impact on virus by using different technology under your control investigation, and we are very impressed. I'm glad that you're able to stay for a little while so that there will be questions to be answered during the Q&A session. Thank you very much, Professor Grün. We go to the next and the last speaker, Mr. Daniel Liu, who is going to share with us the application of sterile fusion technology. Daniel Liu is the Chief Technology and Innovation Officer of McLean Nations in Berhad, a health technology company that has been innovating hygiene for more than 17 years. Daniel leads the development of innovating sustainable and chemical-free technology to turn your water and air into a safe and powerful disinfectant, preventing diseases and improving quality of life. At McLean, Daniel has developed several patents and is responsible for the development of international markets, Asia, Europe, Australia, and North America. Prior to McLean, Daniel spent 21 years in a various senior management position with multinational companies in Asia, Europe, and United States. Daniel holds an honors degree in applied science in mechanical engineering from University of Windsor, Canada. A very impressive credential as well. Over to you, Daniel. The floor is yours. Thank you.
Can you see my slide?
Yes.
Okay. Thank you, Engineer Ong, for the introduction. And I also would like to take this opportunity to thank the organizing committee from MASHRAE and IEM to organize this event, and Professor Gunnar for taking his time to be with us all from Fraunhofer, Germany. With this, let me start my presentation. This is the agenda that I'll be presenting. Let me start with the question, what is Sarah fusion technology all about? Oops, it's not moving, hang on. Okay, so what is Sarah fusion technology? Basically, it is an innovative, sustainable and chemical-free solution that turns your air and water into a safe and powerful disinfectant, preventing diseases and improving quality of life. Sarah fusion technology basically emulates Mother Nature by harnessing one of nature's most powerful and efficient, safe disinfectant called active oxygen. Active oxygen is created, for example, by falling water, thunderstorm, and wave movement. The active oxygen is a combination of negative ions and control level of ozone. Sarah fusion technology basically eradicates bacterial, mobile, and viruses, allergen pollutants, bad smell, cross-contamination, and cross-infection. The Sarah fusion technology is a patented technique to control the production of active oxygen. Depending on the application, the production amount of ozone and negatively charged ion can be varied accordingly. For indoor application, it is designed to operate 24/7 to sterilize your indoor space. The technology are made up of three main components. The sterilization control system deals with the electronics design. The active oxygen electrode module focuses on the mechanics of releasing the active oxygen, and the distributed control system deals with the method of delivering active oxygen into the indoor space. How is it that the active oxygen can purify and sterilize the air? Well, basically, ozone is a very effective oxidizing agent. And when it's attached to the pollutants, it will break down the DNA or the RNA structure of the pollutant at the molecular level, whereas O-, the negatively charged ion, cluster harmful airborne particles together, causing them to fall to the surface. The half-life of O3 is averaging 20 minutes, which gives them sufficient time to be effectively sterilize your indoor space in terms of air and surfaces, as compared to O-, which has a half-life is only a few seconds. But in any way, the combination of both helps to deal with cleaning the indoor space environment. Now, there's a fundamental difference between an air purifier, UVC, versus Sarah fusion technology. And it is important to understand these differences. Firstly, an air purifier or UVC filters clean air that gets drawn into the box, while Sarah fusion, on the other hand, releases active oxygen into the space to fill up the entire space to sterilize not only the air, but also surfaces on a continuous basis. Sarah fusion technology overcomes the limitation faced by air purifier in its ability to filter and treat all the air in the room, including surfaces. Why is the difference crucial? Basically, filtered air or HVAC air delivers into a room do not have antimicrobial property, even though it's a clean air, whereas the active oxygen producing low level of ozone has antimicrobial property to disinfect the indoor space when it's being released continuously. This makes it more effective and efficient in sterilizing the pathogens in the indoor environment. And this outcome is also confirmed from the results of different studies, include what Professor Gunnar has just presented. Now that you have some understanding of sterile fusion technology, let's move on to some application guidelines in using sterile fusion. In this session, I will focus specifically on indoor application. For any indoor application, we need to start by asking these basic questions. What is the coverage volume in the room? What is the expected airflow rate in terms of CFM? What is the expected air exchange per hour? And what is the desired ozone concentration at ambient level? By having this information, then we can determine the ozone generate capacity needed. To determine the ozone generator capacity, here are two formulas that we can use to start developing, to understand the need of the ozone generator capacity. Firstly, is to know what is the basic airflow rate and the desired ozone concentration needed. Together with the air exchange information, we can then calculate the ozone generator capacity. Now, these formulas are typically just theoretical calculation, but it is a good start. There are other important factors to consider before you can determine the final ozone generator output. For example, we need to know the source of oxygen, the airflow, the humidity, the temperature, and the cooling system to finally design the final ozone generator system. Let me run through a couple of examples very quickly. In this case, it's a small room with an air exchange of 4, an area coverage of 25 square meter. And as mentioned earlier, it is important to control the ozone production. So in this case, we want to maintain an ozone concentration at 0.05 ppm at ambient level. With that information, you can calculate the airflow rate and then the ozone generator capacity. Now, in this example, for 250 square feet, the ozone generator capacity calculated is 27.25 milligram per hour. In another example, for example, in the same small room with a lower air exchange of 1, here you find the ozone generator capacity calculated is 6.81. Of course, it will be lesser because the air exchange is very low, and we need to make sure that we still maintain the ozone concentration at 0.05 ppm. This example shows sterile fusion technology is used in a small room of 250 square feet, similar to the example that we have seen. The room here has no ventilation or no air exchange, but it has an average air movement of about 0.09 meter per second. And with that, you see that the time-weighted average of ozone over the 8 hours is 35.89 ppb or 0.035 ppm. So even with a in this example, even with no air exchange, but with some level of air movement, the Versa 25 is still within the OSHA standard, which we mentioned earlier, 0.05 ppm. Okay. Now, in a much larger room, for example, we have the same AH of 4, air exchange of 4, we have a calculated airflow of 3,000. the ozone generator capacity needed for 5,000 square feet based on a O3 concentration of 0.05 ppm, the calculated value is 545 milligram per hour. Now, for a larger room, the Sarah fusion technology can be used with the ozone sensor in place to control the limit. In here, you can see the data log for 12 hours. The time average is 0.04 ppb. If I were to take an average of 8 hours, for example, from 10 a.m. to 6 p.m., the average is about 0.047 ppm. And if I take it at 10 a.m. to 6 p.m., the average is about 0.045 ppm as well. This data is based on 5,000 square feet using AS500D, which covers a 5,000 square area. This is the result of the ozone over the period of 8 hours or 12 hours. Now, what I've shared with the formula earlier is that those formula that we talked about earlier is used for design purposes. However, there are more factors to consider in an actual environment when you select the ozone, to select the proper ozone capacity. So these are the things that we will normally ask and verify before we determine the right ozone capacity to be used. For example, when a customer has a requirement to improve their indoor space, firstly, we need to understand what are the pain points. We need to identify the source of the problems. Is it a mold-related problem, or is it a cigarette smell problem, as an example? We need to understand the layout of the location or the premises with the right dimension so that proper calculation can be determined. And again, the importance of what is the air exchange rate. We need to identify the location of the supply air, the return air, and the total number of persons expected in the room. These are very important parameters before we can suggest any selection of the right ozone capacity to be used. Now, the Sarah fusion technology looks into all these details as compared to a typical ozonizer, which I will briefly go through in the next slide. Firstly, I think it is very important to understand an ozonizer focuses mainly on treatment application. Treatment application as short-term use, okay? The approach is very different from Sarah fusion technology, but most people do not understand the difference, and hopefully with this seminar and further understanding of Sarah fusion technology, there is more clarity. So here, for example, ozone generator, the rule of thumb is for 1,000 milligram per hour, it is used per 100 square feet. And the primary focus here of an ozonizer is to basically to create a high level or shock level of ozone based on a 10 feet ceiling to quickly treat your environment. The typical ozone concentration can be more than 3 ppm and above. If we take the earlier example that we have seen of a room size of 250 square feet, the ozone generator output needed based on this rule of thumb would be 2,500 milligram per hour. Whereas for Sarah fusion technology, the ozone output capacity is only 9 milligram per hour, as you can see earlier in the graph. And the reason is because the Sarah fusion technology maintains the ozone concentration at 0.05 ppm at the ambient level on a continuous basis. Whereas the ozonizer is not meant for that purpose. It is meant to use for quick treatment. So it's a very different philosophy, and it's a very different way of selection in terms of the appropriate measurement. So, of course, even when you use the ozone generator or ozonizer, the treatment time always depending on the contamination type, the level of contamination, the humidity, and the temperature in the environment. With that, let me quickly summarize the difference between the ozone generator and Sera fusion technology. While both can deactivate pathogens, ozone generator is not recommended to use with the presence of human and not recommend to switch on the 24/7 in an indoor environment, and it does not comply to the international standard because it is not designed for continuous use. Whereas the Sera fusion technology is designed to be used in the presence of human being, and that is why it is important to comply to the international public health safety limits, and is used on a continuous basis. So it has a very different philosophy in the design and approach. With that, I'd like to move on to control and monitoring system, which the earlier speakers, few of the earlier speakers talk about the importance of control. And for Sera fusion technology, the patents is all about control and monitoring. Okay. So here are two methods of controlling the O3 concentration at ambient level. These are generally used for larger system. So for example, option 1, it has a ozone sensor attached to the ozone control device. In another option 2, it has a long cable with the sensor where this can be extended to a longer space or bigger room to be able to determine the ozone level at different location. Okay. The option 1, for example, typically can be used in a space between 1,000 to 1,500 square feet, whereas the option 2 can be used as far as 3,000 square feet room space. This is an example of how the ozone control unit is attached to the device to control the switch on and off of the device as it detects the ozone concentration in a room. The device AS440P can actually connect directly to the ozone control unit, but in this case, you see there's an extension cable, so you can have multiple extension cable, in this case up to 2, that the device can control. This is an example that has been installed in Germany, where you can see there are 2 AS50G installed on the ceiling, and this is the ozone control unit that are connected. Okay, the cables are all hidden, of course, so you can't see that, but this device is actually controlling the on-off time of these 2 devices with a preset level of 0.05 ppm. For larger units, the Sera fusion technology has IoT features in controlling the ozone and also monitoring it. Here, for example, the overview of the dashboard, you will be able to determine the device information, and you can also have an overview of the system status. For example, here, there's 1 ozone sensor attached to the device, and there's a lot of alert systems that are being monitored to determine the health of the device and also the ozone sensor and the limit. And in this slide, you can actually see that the location of the device and the installation information is also attached. And beside that, you can see there's a graph where the ozone sensor is collecting the ambient ozone level and plotted against the threshold, and it will calculate the time-weighted average as it moves along over the time. So these are all real-time data log. And below, you can also see that each device is able to have 3 ozone sensors attached. So you can actually have multiple ozone sensor in a space that if you want it, if you want to install more ozone sensor, especially in a much larger space area. Okay, so these are just few examples of how the Sarah fusion technology are used and also control the ozone level for especially large system. Now, I'd like to now finish off with some implementation of Sarah fusion technology. Here, let me just go through some of the few examples. Starting with cinema halls, we have done 6 cinemas servicing 21 cinema halls in Germany, in line with the study by Fraunhofer Institute. We have also installed Sarah fusion in GSC Orem, in the Gardens and Mid Valley, South Key in Johor. Okay. So this is cinema. And we have also installed the Sarah fusion technology in toilets in Changi Airport and Seletar Airport at this, at this moment. And we are continually extending our implementation, especially in Changi Airport, in more of the public toilet areas. The Sarah fusion technology is also installed in a supermarket chain in Malaysia. This is Jaya Grocer. We have installed nationwide, all in all about 40 supermarkets from Jaya Grocer. And we have also installed Sarah fusion technology in large casino halls. In this case here is Resort World Genting. But we also have done actually few other casinos, smaller casinos in Vietnam, to sterilize, in this case in Vietnam, is the cigarette smell in this casino. Other places that we have installed or Sarah fusion has been implemented. We have done many office building. This in particular, we have done in M-Bank offices. In total, I think we have done 62 floors. We have done Watson offices, EcoWorld, IGM, and many more commercial buildings. Okay, and in this particular slide, you can actually see the dangler where the customers want to educate the employees and the staff that the company has taken action to improve the hygiene in the indoor space. For central kitchen, in this example, in Convention Center, we have done in Singapore Expo. We have actually also done in KLCC Convention Center. In auditorium, we have done actually in Monash University. In fact, all of their auditorium are fitted with Sarah fusion technology. We have also done auditorium in Marina One and the School of Arts in Singapore. So, and last but not least, we also have done in big malls. For example, this is one of the latest implementation along the entire corridor of basement in Marina One Mall in Singapore. This covers about 50,000 square feet area. So what you can see here is a various implementation of Sarah fusion in different environment, different industry, helping to improve the hygiene in the indoor space. With that, I'd like to play a short video clip that is implemented in the German in the cinema in Germany that has installed Sarah fusion technology.
Sehr geehrtes Publikum, liebe Cineasten, herzlichen Glückwunsch, Sie haben die richtige Wahl getroffen. In diesem Theater werden Luft und Oberflächen kontinuierlich mit modernster Sarah fusion Technologie gereinigt. Die grüne Technologie arbeitet ohne Chemie, ohne Filter und unter minimalem Energieeinsatz. Die Sarah fusion Technologie von Medclin nimmt sich die Natur zum Vorbild. Sie sorgt dafür, dass die bestehende Raumluft sich selbst wie etwa nach einem Gewitter reinigt und von Schadstoffen befreit. Dies bedeutet, dass die Virenlast um 99,9% gesenkt werden kann und die Raumluft für alle sicherer wird. Weitere Informationen finden Sie unter www.medclin.de. Wir wünschen Ihnen viel Spaß.
So in conclusion, the Sarah fusion technologies offers efficient and very effective solution. It has been established over the last 17 years and has been tested and proven by many different independent institutions, tested beyond the lab, deployed internationally around the region, and is a very sustainable and chemical-free solution, very cost-effective, and importantly, it complies to international standard with the low ozone concentration. So with that, I conclude my presentation. Thank you very much. Back to Engineer Ong.
Thank you, Daniel, for the very impressive sharing, which I understand Zero-Fusion technology is designed and made in Malaysia and patented worldwide. Yeah? So this is a pride of the Malaysian organization for the matter. But of course, your sharing on ozone calculator and control monitoring and case studies are very interesting for us to know the use of this technology for better environment and also better preventions of the transmissions of diseases. Now, we are coming to the Q&A and to be answered by the panel speakers. Now, since we are overrun by 5 minutes, I just want to ask the panel speaker, would it be okay that we make it half an hour, because there are many questions being posed. It seems that your topics are so exciting that there are a lot of questions being raised. So is it okay that we extend the Q&A until 5:10? No objection, right? No violent objection, I hope. Okay, good. Thank you.
I need to leave at 11 my time, so in 20 minutes.
All right, thank you, Prof. Yeah, we'll try to pose a question to you so that you can have your time for other commitment. Thank you so much. Now, it seems that we received a few questions. We received 9 questions from among the floor, 10 questions from among the floor right now, and there are a couple of them, a few of them which has been sent to my iPhone, some of my friends. So I think to start with, the question is on ozone, because ozone has been something that has been discussed quite widely among most of the speakers here right now. One of the participant, Jim Lin, asking, it's not, this one is by, by Sinju Yong, sorry. Sinju Yong asked, at ozone concentration below 0.05 parts per million, okay, are the byproducts within the threshold limits? I guess he meant are the byproducts within the safety limits. Okay, so at concentration below 0.05 parts per million are the byproducts within the threshold limit or safety limits. So panel speakers, over to you. Okay, Prof. Grün.
I may answer if you like.
Sure. Thank you, Prof.
So typically this threshold is the threshold set so that we don't get irritation by ozone for human beings. Yeah, and that was exactly the question we had also, and that was why we initiated this additional small laboratory study, which I showed, with VOCs emitted from persons in that case, because we were looking at crowded spaces. And we have seen that at this level also the formed byproducts were below all the occupational safety levels which we typically have. So it was safe to operate at these low levels of ozone. Also with respect of the produced byproducts in an artificial setting with high levels of VOC production.
Thank you, Prof. I think it's very comforting to know that at 0.05 and below is safe to be used. Thank you. The next question is from one Mr. Lau Ka Hu. How do we as a consumer knows if an air sterilizer only produces controlled ozone? Question is, how do we as a consumer knows if an air sterilizer only produces controlled ozone? Okay, Professor Grün, thank you. Over to you.
I can take over that question, but others are also welcome to do that. But first of all, I would always say, if you buy an air cleaning device, you should look if the producer tested if the device produces ozone and if it produces considerable amounts of ozone. Some do, and as I showed, it's not a problem if they do produce ozone, as long as the level remains low enough. The only way how you know that not too much ozone is present in your air is, as engineer also mentioned, that you need to monitor it. Yeah. Without monitoring, you never know how much ozone you have in your air. Not now, and not with the presence of an air purification device. So you need to look at, does the air purification device produces ozone? If so, you should monitor ozone. That's the simple answer to the question.
Okay, thank you, Professor Grün. Thank you. Next question is from, I presume, is Dr. Adel Azim. He asked, what is the cause of ozone level increase? What is the cause of ozone level being increased? I guess that's what he meant. Is there what are the causes, or what is the cause of ozone level being increased? So it's a question. Okay, Professor Grün, again, thank you. Since you're the expert,
I can take over that one, but Daniel does know that also very well. On the one hand side, of course, if you put energy into the air, that will lead to reactions, some reactions. And in the case of activation of oxygen activation, you produce ozone because you know it. In other cases, such as UVC lamps, if you have the right wavelength, or the wrong wavelength in that case, they produce also ozone because they activate the combination of oxygen ions with oxygen, and then you get O3. And ozone is typically also very reactive and builds up, and but also decreases again when it reacts. So that's why that's the cause of ozone increase. Like putting energy into the air by some means, for example, by UVC, also by ionization, plasma reaction, all those purification technologies that produce energy may also lead to ozone production.
Thank you, Prof. The fact that we're able to answer so effectively, I think we're able to entertain more questions in the short one. One more question to you, Prof, because this is a friend that texts me asking specifically based on the viral load reduction study that you have conducted and investigated, while both the air purifier technologies are effective in reducing the viral loads. Fusion is able to reduce the viral load faster compared to the upper UVC from the results of your investigation. Now, is this the right way to interpret?
Yes. So the case with the activation oxygen was quicker than the other one, which was also naturally because the activated oxygen is present in all of the room areas, while the UVC, the upper air UVC, is just in the above your head, because the human being should not be exposed to the UVC. So all the small viruses need to travel into the UVC zone. In the activated oxygen case, it's present everywhere, so it's also quicker.
Thank you, Prof. I think this answer should be able to satisfy the inquirer. Now we got one question is from perhaps also from Dr. Adel Azim as well. The question is, since electrostatic filter are using electrical power supply to operate inside the HU, which will have possibility of condensation, how far can it withstand water in the situations of HU it being flooded? Yeah.
Okay, I think it's my turn to answer this one.
Good, Engineer Chen.
Okay, ESP filters, typically you install it on the return air side. That means the on side of the coil, not the off coil side. Okay, so you don't get exposed to very cold air that gets condensation because it's on the return air side. And also, when you talk about water for this sort of products, ESP products, in fact, you'll be surprised that you know how do you clean this sort of filters. You don't do it the traditional way of cleaning it. The most effective way is actually, of course, without power supply, you actually put into water and use frequency to clean it up. So there's no problem at all. So it can be exposed to water, but condensation, no issue. It's only electrical parts that you're worried about. So there's never any problem with that. Okay, I hope that's very clear.
Thank you, Engineer Chen. There's one generic question from anonymous attendee. Question is, opening the vent inside a car will introduce other contaminants such as carbon monoxide into the car, won't it? Okay, I think this is a general question, any one of you. Okay, yeah, Dr. King, yes.
I think I answered the question. So basically, when we try to introduce the outdoor air or outside air, we have to evaluate the air qualities. So that is also important to keep in mind. That's why there's a lot of additional technologies that actually can substitute the outside air, and also other precautions that we have to take to prevent this spread of the virus, like wearing masks and so on. Thank you.
I can't resist not adding on to it. Okay, when you talk about ventilation of air in your car, you never open the vent when you're caught in a traffic jam. It's understood. Okay, you don't sit there. You open everything, even open car window when you're in the countryside. So obviously, the air in the city or polluted area is no good for not only for cars but even air intake.
Thank you, Dr. King, and also Engineer Chen. This is another question which is sent to my handphone, asking, what is the equivalent CADR of ionization technology? What is the equivalent CADR of ionization technologies? Anyone?
Okay, this one I have to take up for the, okay, when we did the MVC, and of course this is a direction that most of the standards on all this equivalent ventilation and outdoor air are going towards to. We need to have a common metric. Okay, of course the efficiency and efficacy of different technologies are different. For example, ozonization, it can react by deactivating the pathogen faster, and the ventilation rate and all that. These are differences, but we still need to have a common CADR method. So in ionization, this is a very important, or what I call that, interesting question, because ionization works in two ways. So one way is actually what we call sterilization. Of course, there are some research and some people selling. Of course, ionization also got a lot of types: corona, discharge, plasma, and all that. Some of them claim to have this what I call that sterilization. So of course, if it's sterilization, then it will be the same way as how we calculate the time required to bring the concentration of the pathogen to a safe level within a certain time frame. So you have the volume, you have the time, then we can estimate the equivalent CADR. This is how we do in MVC as well. The second way why ionization works, and then of course some people, they also claim that that's how the ionization works, like corona discharge type, actually agglomeration. That means they're actually claiming that different charges actually makes the particle larger. It attracts smaller particles into large particles, and because of that, it increases the filtration efficiency of your existing filter. So this one become a bit tricky because you may be able to use a lower rate filter but capture larger particles because of the effect of agglomeration. Okay, and then these people claim that yes, they have widely used this technology in clean rooms and all that, where this ionization technology actually increase the efficiency of filtration. So basically, this one we are waiting. We hope that people who are doing research in these areas will actually give structure the research in a way that we can actually quantify the effect of on the filtration. That means we can use a lower filter, but we can, because of ionization, we can actually increase the efficiency of capture of particulate. Yeah, thank you.
Thank you, Engineer Ao. Thank you. I missed this question. This one is from Engineer Yeong Jin, the past president of MASHRAE Malaysia chapter, also related to ozone. The question is, how does fusion technology ensure effective distributions of ozone and add disinfection for room space with several configuration? That means a room which is of a irregular room space design. How does fusion technology ensure effective distributions of ozone and air disinfection for room space with several configuration?
Okay, I will take up the question since it's fusion.
Okay, Daniel. Good.
Basically, for large spaces with multiple rooms, for example, or different sizes. As I mentioned in my presentation, we look in several factors. We will look at the airflow distribution, where the supplies are coming in, where the air returns, and of course, the overall layout of the space. The technology used here will be what we call the fusion distributed system, similar to what is being used in the study by Professor Gunnar in the cinema. So we will place the nozzle either on ceiling based on the coverage area, so that the nozzle is placed in multiple strategic locations where the active oxygen is then released to ensure there's a equal distribution to the entire space. So this is how it's done. And as I mentioned too, we do have a monitoring system and it's being monitored in different locations as well. So there are different methodology used, but in general, that's how we implement fusion in large spaces with multiple different sizes of room, different air circulation or air movement as well. So I hope that answered the question. Thank you.
Thank you, Daniel. This another question is sent to my mobile. Question is, of the 6 or the 7 entrenched technology, I guess this one is directed to Engineer Chen. Which one offers the most value for money for the setting of one new setting and the B for existing building? So the question is, I want to repeat, out of the 6 or 7 entrenched technology, which one offer the most value for money for setting of a new setting and B for existing building?
Okay, to answer that, that's the reason why the MVC was developed. Okay, I think out in this current presentation didn't go through all the features of this MVC. In the MVC, you actually get to key in, right, the cost of whatever you adopt, and then you calculates the energy penalty, and then you get an overall result. You say that which one will actually be more value for money. I think maybe I would like to elaborate on that because it is addressed in the MVC.
Okay, thank you, Engineer Chen. Engineer Ao, if you want to elaborate.
Unmute first, please.
Unmute, please. Yeah, unmute.
Oh, sorry. Okay. I just put on the screen already. This Excel is very easy to use. So basically, if you have now all these seminars educate us how to actually calculate all these equivalent CADR. As we have more testing, third-party testing, we have more information. Let's say, for example, how big of an area, what is the air change, and what is the equivalent ventilation rate, which is being transferred over here. And you can actually put a cost price in, okay? What is the CAPEX and all that. And then you can actually, by the end of the day, you can actually get all the total cost here. Of course, you can also compare the different costs. Let's say, for example, you need 3 units of 500 portable air purifier, then your cost is this, then this is your total cost. This CADR will include and add on to all the equivalent outdoor air we are requiring. So basically, and then if you have an additional pre-cool unit, this is also, this is for the aircon price, but for the equipment price, you can actually key in based on the different quotation that you actually get. So I actually allowed for different strategies. Say, for example, other equipment and system. If you have the figures for the ionization, you can actually key in here as well, how many units. And there's also a different, let's say, for example, for controlled sterilization, there is a test result that show that in 10 minutes, it deactivate all the pathogen virus. This is a test volume. That's how you get a CADR. If you have other systems, you can actually key in here as well. So basically, this is flexible. If you need 20 liters per second of outdoor air, just change 20 here, then it will change. So basically, what Engineer Chen just now mentioned, we have a cost element here for you to actually compare different strategies. Okay.
Excellent.
Okay.
Thank you, Engineer Ao. Thank you. Now, there's one question that also sent to my mobile, saying that in the presentation of the first speaker, who is Dr. King, can you please elaborate your two broad set of operating conditions, the normal and epidemic states? Because that was the slides that you put in, so they would like to ask you that question. Yeah, Dr. King, over to you, please.
Okay, I think at the moment there is still no general standards that mention what should be the epidemic setting. But for sure, in Malaysia context, then we have the UBBL and so on that actually specify the minimum ventilation rate and so on. So I think a lot of this is still under development, including the ASHRAE, the new standard, the 241P. So that's why if any, you can feedback to the standards, and ASHRAE will take your feedbacks and we will revise accordingly. So hopefully the standard will give a clearer overview of what the recommendation, what can we do for the this high risk setting. Thank you.
Thank you, Dr. King. I think the rate we go, we probably can take a couple more, three or four more questions, because I still have 3 or 4 more questions on hand right now. One of these is on the serofusion technology. It's from this Mr. Jim Lim. He asks, serofusion technology reduces the viral load faster than upper UVC, even though serofusion is tested in a larger cinema according to the result. Is this correct based on what you present?
I think Professor Gunnar already answered that earlier on.
Professor answered that, huh? Okay, okay, right. Then the next question will be from.
I need to leave now. Do you have a question for me in the panel? Then I quickly can answer that one.
I think there's no more question for you, Professor Gunnar. I think
no question for me.
Yes, no more. I think all your questions have been answered very.
I already chatted my goodbye, and thank you very much.
Okay,
thank you
to join.
Thank you, Professor.
Thank you, Professor.
Would be glad to stay in contact.
Yeah.
Thank you.
Thank you.
Exactly.
Have a good morning. See you.
Yes.
Bye bye.
Thank you. Bye bye.
Right.
Bye.
Right, Professor Grün, Gunnar is leaving us because he's from Germany and he's still got other commitment. Okay, thank you very much to him for all the way joining us from Germany. Now, I just want to go to another question, which is from our engineer Leong Xiu-Ming. What are the cost-effective air cleaning technologies for residential and non-residential settings? What are the cost-effective air cleaning technologies? Okay, there are 2 for residential and for non-residential settings.
Who wants to answer that? Okay. Okay. First of all, what are the technologies that are recommended? Okay, I've already shown you in my tables my own assessment, so you can identify which one, and then to decide whether it's cost effective or not, use the MVC. Then you decide whether which one is more cost effective. I hope, Engineer Leong, that will satisfy you.
Okay, thank you, Engineer Chen. I'm sure Engineer Leong will be satisfied with the answer. Now, the other one is from one anonymous attendees, participant. Is towards Adeno is on a serofusion technology. What is the budgetary price? Any rule of thumb to calculate the estimates? So I'm not too sure what question. Maybe, Daniel, you are able to answer that. Over to you.
Yeah, this is a too general question to talk about budgetary price, because normally we look at as I mentioned earlier in the presentation, we look at the specific issues that we need to tackle. So for example, whether it's just a standard room where somebody wants to improve the hygiene of the space, or is it a much polluted environment where you have, for example, in the smoking room. So to treat the smoking room and to treat a normal room of an equal size, the budgetary cost will be very different. So it's very hard to just give a general number at this stage. So
could I attempt to simplify his question from a layman angle? Perhaps very simply, if you buy a portable air purifier, it's for a space within your house. Okay, if you don't want to use a portable purifier, you want to use a Serafusion unit. Okay, how much is the unit cost?
Well, maybe I will answer to give a general answer. For example, in a home use, a typical space of about let's say 450 square feet space, the budgetary cost will be about 1,000 ringgit. Okay, so that's the household environment. But if you talk about office space, so the budgetary cost can actually run from few hundred to few thousands of dollars. So it very much depends on the space. But what I can say is that many of our implementation done is that the larger the space, the much more cost effective it is. And we have done a comparison with different technologies, and we can say confidently the price is much more cost effective. But to get a more specific comparison, I think the MVC is a very good tool to use. So it gives you a non-biased method of working out the budget and also do a cost comparison. So I think that would be a good tool to use. And if you need specific help, I'm sure Engineer R will be more than willing to help, or we can even help you to work out some of these budgetary information. Yeah. I think that would be a better way.
Thank you, Daniel. There's another question by Mr. Lau Kahu. He asked, what will happen if we install a large capacity Serafusion ionizer in a small room? What will happen if we install a large capacity your ionizer in a small room?
Firstly, we do not recommend it. Again, I think in the context of compliances, we need to make sure that it is used appropriately and within the safety limit. So this is a very important factor, and I think we hear a lot from the speakers, different speakers today as well. So if somebody were to come to us and say, oh, I have a small room and I want to use a large capacity device, we will say, no, you don't use it unless you're talking about specific purpose. For example, a treatment where you want to treat the room and there's no presence of human being. Then yes, you can do it. But in the presence of human, we say, no, you shouldn't be using that. So I think it's very important to understand how to use technology in the appropriate environment, especially a solution that has to comply with, safety. Yeah.
Thank you. We are coming to, I left with two questions. So I just, probably we can extend a couple more minutes. So one question is from Joni Chai. How do we know that the UV dosage is enough to kill the viruses in the room? Question is, how do we know that the UV dosage is enough to kill the viruses in the room? Any speakers?
I can maybe briefly answer that. I can't remember the figure, but what I can say is that it's not just about the UV dosage, but also the time. You need to understand the UV dosage and the contact time. These two parameters is very important to determine whether it has sufficient dosage to kill the virus. And there are quite a number of studies shown. And what I can say, unfortunately, a lot of the research studies shown is that most devices out in the market do not have sufficient UV dosage and time to kill the viruses. So I think it's good to do your homework to understand the data properly so that you know confidently whether it can kill or not. So just like, again, data is very important, independent data to help you make that decision.
And can I add on to it? Because this particular webinar 3, we have shown calculations, and in particular, the speaker has shown the weather fusion calculation. But in the webinar 2, we had a lot of speakers on UV, and I recall all the speakers on UV actually give examples of calculation with the time and so on. So we can refer back to the slides. It's all there. Okay.
Thank you, Daniel and Engineer Chen. Last question. I think this one also sent to my handphone. Question is directed to Dr. King. Any maintenance-free system? Anything that is free, we want to know.
There is a question I throw to participants.
Oh,
So
okay,
if someone come and tell you that my system is maintenance free, then you better evaluate, because for example, even a lamp, then they can be covered with the dust. So the efficiency over the time, it will be deteriorated. And I think I put up the question is just to ask everyone to be cautious and to ask for more information, especially scientific data, before they go into select any, especially the emerging technologies, right, where we are not all do not know how exactly want to use the technologies.
Thank you. Exactly. My friend is excited that there is a maintenance-free technology that he wanted to promote or want to buy or wanted to be your agent for the technology. Thank you very much. I think we are coming to the end. We have already overrun our time. It's supposedly to end at 5. I'm really thankful to all the speakers for your patience, your sharing your knowledge, where I'm sure all the participants benefit a lot. Okay, and we hope that probably MASHRAE Malaysia chapter and IEM will again organize a similar kind of a webinar that can benefit not only the engineers and the participants in Malaysia, but also, as you heard just now, there are 8 other country participants joining us in this webinar. Now, so I want to thank every one of you, especially the speakers, for your effort and time, from which both MASHRAE Malaysia chapter and also IEM thank all of you profusely for your contribution to the community and also the society as well. Thank you. But before we leave, I just want to inform all the participants that the certificate attendance will be emailed to all of you, but wait for a few days, so IEM Secretariat will be able to send it to you. So you have your certificates of attendance, and you need the CPD hours will be in the certificate attendance. Second one, now please answer the survey on the performance of this webinar. When you answer, then you'll be able to receive the presentation material of all the 5 eminent speakers that we assembled today. So let me see, the link over there for all of you.
1 second, Engineer Ong, I will share. Yeah, just give me a second.
Okay, there will be a link and also probably the QR code for all of you to take it, and then you're able to respond to the survey. And once you have responded to the survey, then the presentation material will be emailed to you. But please allow us a few days to send it out to you. But for those who don't respond, I'm sorry, because we are not able to send it to you, because we really need you to be able to feedback to us. How do we fare in organizing this webinar? I believe it's excellent. Personally, I think it's awesome. Okay, but I will want to listen from you. We want to hear from you. Please give us feedback, and then you will receive these very precious presentation material from all the experts and also the leading authorities of this M&E industry, and also from Germany as well. Okay, now while waiting for Rosalind, the Secretary of IEM, to upload the link for you to do the survey, our distinguished speakers, if you need to leave due to your commitment, you are able to do that. But before we leave, I forgot, we should have taken a picture. Okay. All right. In front of us, you have the QR code and also the link for your for you to respond to the survey. Yeah, please take the QR and also the link as well. All right. It's very short. HTTPS short URL at CFGIK. Yeah, for the slides. Huh? Okay. HTTPS short URL dot at CFGIK. All right. So before we leave, can we have the
Later on, if any of you would not catch the QR code or the link, can just email to me. I will share the QR code and the link to you. No worries.
Thank you, Rosalind. So you have a confirmed in the event that you're not able to take the QR code or you're not able to capture the link that is shown in front of us.
Yeah. So I will stop.
Okay, excellent.
Share, then we will take.
Okay. All right. Let's take a picture among all the esteemed, distinguished speaker of the day. Again, on behalf of MASHRAE Malaysia chapter and IEM, our profound thanks to all of you for your immense contribution. Thank you.